without fail, as soon as we start up the stream, it gets super windy. Hello everybody, and welcome back to Paleontologizing. It's wonderful to have you here today, back in Montana in the Judith River Formation, or is it the Dinosaur Park Formation? We'll be talking about that today, but glad you could make it. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. You know, trying to show you firsthand what fossil science is all about. And most of the time I'm streaming from, well, most of the time. For about 9 months out of the year, maybe 8 months, I'm streaming from my office back in the San Francisco Bay Area, going over new scientific papers, interviewing other paleontologists, doing 3D printing, and tons of Q&A with the audience. But right now, it's summertime, and in the summer, I'm doing field work. I'm here with the Badlands Dinosaur Museum crew from Dickinson, North Dakota. Although folks here are from all over the country and from other countries as well. And we're at the Jack's Bone Bed site. First time streaming from here, very excited. We've got some incredible stuff coming out of this bone bed. We'll be talking about that today. We'll be discussing the various kinds of critters that we're excavating. We'll be talking about the geology of this area. We'll be talking about paleontology in general and why it's important, and then we'll be talking about whatever you're curious about, as long as it's semi-on topic. But welcome. It's good to have you here. And we do have a tractor, Claire Burr. Yes, indeed. Pretty exciting. Helping us with the overburden here. We'll ask Denver about that. But yeah, good stuff. How's everybody doing? You all having a good morning, afternoon, evening, middle of the night? Maybe you don't know what time it is where you are. At any rate, I'm glad you're here. Welcome to Paleontologizing. And a good time zone to all. Yes, thank you, Claire. Good stuff. This, like I said, is the Jack's Bone Bed site. I've been hearing about this site for years in the field reports of the Badlands Dinosaur Museum, and here I am on site, eager to show you around, so we'll do that. And I think the star of our stream today is over here in the orange. There's Dr. Denver Fowler, curator of the Badlands Dinosaur Museum in Dickinson, North Dakota. How you doing, Denver?
Hi, Danny.
Yeah. And yeah, we'll be walking around talking about this stuff. I might be doing some digging on camera. We'll see what today's stream holds. But yeah, will you tell us a little bit about this site, then?
So this site was found, I think, 2020.
Okay.
Me and Jack Wilson were doing our second year at the top end of this coulee, and looking in the new sites. And I think Jack had found some bones at the top of the cliff, and then I got a kidney stone and we had to go to the hospital. But we came back a few weeks later,
yeah.
And just over to the right here, we had a piece of bone sticking out, and there was lots of bone coming out all the way along this sandstone ridge. But there was another piece just around the corner from the same layer that Jack started digging around, and he basically uncovered this whole lower jaw of a lambeosaurine. So that was in 2020. We came back in 2021 with an excavation permit, and we've been here every year ever since.
Shoot, yeah.
And it's the same horizon that's kicking out about 30 meters maybe. It's quite boring, and it's just an old channel deposit. Lots of animals died, fell into a channel, and got washed up on a point bar. But it's fabulous in the sense that it gives us a really good window into all the different species that lived in this formation, and we're getting all the really interesting rare stuff at this site too. So it started off with a lambeosaur, which turned into a much more exciting discovery, and it's really just not stopped. We've been 5 years, I think, about a year.
Awesome. So give us a short laundry list of the different critters you have from here.
So over by where the lambeosaur jaw was found, behind that we had the rest of the skull. And then with that, it moved around a little bit, but we have most of the skeleton.
So this is the famous Liberty Lambeosaurus, right?
Yep, this is Liberty the Lambeosaurus.
Nice.
So it's got a complete articulated neck, but that's pulled away from the torso a bit. And then we mostly have a mostly articulated torso all the way to the base of the tail,
Nice.
and then all the way down the leg, and an arm on one side. And it's got skin as well, a lot of skin.
Nice.
And then near that, we've actually found, well, I'll talk about this area.
Yeah.
And then when this was being dug, we at first thought we were just going to find big bones, because we mostly saw quite large bones sticking out. So we were digging down, and about halfway down through the sandstone, we start coming across lots of little bones. And I found a fragment that I thought looked like pterosaur. I thought, well, you know, you find fragments of pterosaur every now and then, but it's always worth keeping an eye open when you found one. And lo and behold, we start finding more pterosaur. So we actually have what is probably now the most complete pterosaur skeleton from Montana.
Holy cow.
Coming out of this site. It's all scattered. Everything here is scattered, mostly. Sometimes it's clumped, but usually disarticulated, especially the small stuff. So we have this pterosaur, and then next to the pterosaur, we start finding these little black theropod bones. That turns into a troodontid.
Nice.
I think last year we got part of a Sauronothelestes, so a little velociraptor skull came out of here.
Yep.
And many of the small vertebrae and things might be from that guy. And then the most recent, well, I suppose second most recent was part of a caenignathed skeleton.
Nice.
So we have
Oviraptorosaur, yeah.
Yeah, it looks like we've got most of an arm. So we have the hand, articulated hand. We have bird is it's one that's has been worked on by Lauren Wilson.
Oh, okay, nice.
Who's Jack Wilson's wife.
Yeah.
And Jack Wilson found this site originally, so that's nice.
Very cool.
And she's working on it in association with some material from Canada and also from Mongolia.
Nice.
And our material is basically it's the only specimen, the only element of its kind from that kind of bird.
Nice.
In North America.
Holy cow, that's exciting.
We're hoping we'll find more of it. I mean, Taya, who's just up at the end, she found part of the knee joint last year, which was very exciting because that's when Lauren was looking at the rest of it.
Okay.
Yeah.
Cool. Shoot, so like I was saying, really exciting site here. That's not, I don't know, I'm not overselling it. This is, I was talking with Denver earlier, probably one of the most important dinosaur sites in this part of Montana. And it's going to keep yielding stuff for a long time. You do see the heavy equipment in the background. Local guy that Denver has asked to clear away some of this overburden. So down here, this is the productive layer. It's actually kicking out all of these bones and other elements. But normally at a site like this, we just remove all of the overlying rock by hand, and it takes a very long time. We're lucky enough to be able to have some help with that, which is saving us literally weeks and weeks of hard labor. So we're really grateful for the help. And it's part of a theme you'll be hearing about a lot today is efficiency in a good way. Doing a lot with not really a whole lot of resources. That's one of the things that the Badlands Dinosaur Museum is very good at under Denver's leadership. And this is part of that. Clearing away that overburden gives us a chance to be able to work in the productive layer and keep finding more stuff and kind of filling in the blank spots on the map when it comes to this geological formation. We'll be talking about the identity of this geological formation too, because that's some new and intriguing stuff. But anyway, Sigarado wants to know, how does this site differ from the previous stream sites? So the one I was at yesterday, the 2-yoke site, is a dinosaur egg site. And it's also yielding bones from various critters, including like a juvenile or subadult duckbill dinosaur. This is different in that we don't have eggs here, but we've got like a whole smattering of different critters that lived in this environment. It's an overused term at this point by me, but it's a nice sample platter of the different critters that we have living in this ancient environment. And that turns out to be really important for this site in particular because, as we'll hear from Denver in a little bit, even though this is officially mapped as the Judith River Formation, that's not what the critters are telling us. This is more consistent with a different from Canada. So that'll be an interesting discussion in a little bit. Stay tuned. Yeah, and Moxie Drinker says, do you check the stuff that is being cleared for fossils? No. You'll see this bucket over here. It's got a bunch of matrix in it. And this is going to be brought back to the laboratory and screen washed. So this is a particular layer from in there that's been yielding all kinds of cool elements. And so this will be brought back to the laboratory, put through some water and through a sieve. And then there might be little bone fragments, there might be teeth, there might be fish scales, there might be all kinds of different elements in there that are not easy to spot when we're in the field. We're trying to work down through this and find big elements and find small stuff too, but the teeny tiny stuff, say your mammal teeth and things like that, which can be really scientifically important. It'll be nice to be able to sift through that stuff back in the laboratory under controlled conditions when we've got more time. That's another thing you'll hear me talking a lot about this summer is when you're in the field, you've got a limited time out here, limited budget, you're doing whatever you can while you're out here. And then if you can bring material back to the laboratory, then you can work on it throughout the rest of the year. One question that I get a lot during these streams is, well, why do you guys always work during the summer? Well, that's the one time of the year when this landscape is not covered up by snow. We do even occasionally get snow during the summer too. But anyway, Montana is not a particularly hospitable place during the winters. And so, we make hay while the sun is shining, so to speak. You do the field work during the field season while you can, and then you bring stuff back to the lab and you do that for the rest of the year. So yeah. Good stuff. And does paleontology, sieving, or washing have a specific name? Yeah, we call it screen washing. Oftentimes it's the paleontologists who work on small critters, like say Mesozoic mammals, who do a lot of screen washing. But you'll find mammal pieces, you'll find bits of lizards, salamanders, and other amphibians, freshwater fishes, both bony and chondrichthyan. Lots of little critters come out during the screen washing process. So, yeah. And have you found anything cool? Absolutely. Most hat unloved. Here. Sorry, your username is like almost the same color as the backdrop, so it's a little hard to read. And Moxie Drinker says, how late in the season can you work this site? They'll be working here throughout the rest of the summer, I think basically until the end of August. That's generally kind of the safe time. You get into September and the weather can turn sometimes. So, I don't know. In Montana, winter can fall fast and sometimes unexpectedly. And Claiming Light says, why is this site more likely to have remains than any other? You mean as opposed to the site I was at yesterday, or? Oh, you're talking about how do we find sites in the first place? This is like the most common question I get on stream. I'm glad you asked it. So Jack Wilson originally discovered this site through what we call prospecting. So walking along and looking at the rock. So here, let's go over here for a second. I'll still be in range of the satellite dish. Once you have the correct kind of region picked out, you know that you're looking at rocks of the right age and the right type to be able to find critters like, say, dinosaurs that you want to find. Then when you're actually there on location, you do what we call prospecting. So you walk along and you're looking at the ground you're looking for anything that might seem a little bit unusual, like, oh, here we go. There's some bone fragments right there. So you can tell, based on the and all of that, this is bone right here. You find little bits of bone that are eroding out of the hillside, and then you follow them up, almost like a trail of breadcrumbs. You dig in, and if you're lucky, you find an associated skeleton there. Maybe even multiple skeletons. Or at this site, you find a bunch of skeletons, but they're all disarticulated. Everything's all scattered, all broken up. So we're finding little intriguing bits and pieces of different critters. So anyway, prospecting is how we do that. It requires a lot of walking around. In order to find something really good, often you've got to prospect all day, or sometimes multiple days before you find anything that's really worth digging into. And this is one of these sites that Jack Wilson found this, like Denver said, back in 2020, and it's been yielding stuff ever since. So this is really a world-class site here. Other sites, you might have a partial skeleton. Maybe you spend a week or so digging it up and then you move on because it kind of runs out. This is just yielding more and more and more material here. And why is it doing that? Well, it has to do with the ancient environment. So this is what we call a channel lag. So this is where you've got a river going through, flowing water, and then it kind of slows down at a certain spot. Maybe you have like a point bar, so like a big sandbar in the river. And then the river kind of slows down in that spot, and stuff that it's carrying, bones, teeth, claws, etc., those will settle down to the bottom and get buried. So we call that a channel lag, because it lags, it slows down, and stuff falls out of suspension. So we're lucky that this was kind of one of those slow spots in the river where you get a lot of different elements being, elements of different animals, bones, teeth, claws, etc., falling out right there and then getting buried by sediment. Yeah. Anywho, good stuff. And Sicaratus says, what are you expecting to find in this site? It's not so much what we're expecting to find, it's what we have found already. This site has been worked for about 5 years now, and it's yielded all kinds of really cool stuff, like Denver was saying earlier. Maybe you missed that. But there's a beautiful Lambeosaurus skeleton just over the ridge. And then they were digging that up, excavated the skull, it's beautiful. And then they decided to come over here, and there's bones spilling out all over the place, so they dug in. They're finding most of the different dinosaurs that lived in this formation, bits and pieces of them. Everything from Oviraptorosaurs to ornithomimids, dromaeosaurs, your raptor dinosaurs like from Jurassic Park, troodontids, ceratopsians, horned dinosaurs, bits of duckbill, hadrosaurs, and pterosaurs too, the flying reptiles, what many members of the public call pterodactyls. Their bones are extraordinarily rare. Maybe you'll find a few bits and pieces here and there, but here they've got pieces coming out all over the place. Like Denver was saying, probably the most complete pterosaur from Montana yet discovered is from this site. So all kinds of amazing stuff. So yeah. And there we go. I knew that you'd be curious about that, Alexander. Let's maybe go bug Denver for a second and ask about the crocs. But you know what? Before we do that, let's meet some of the crew members here at the site, people we haven't met before yet. So let me go bug Taya for a second. How you doing, Taya?
I'm okay. Yourself?
Yeah, doing well. Thanks. Yeah, we've got 227 people watching so far.
Oh,
so
wow.
Don't be too camera shy. Yeah, Taya, where are you from, and how'd you get involved with this?
So I am a recently graduated PhD student, so now I have a doctorate.
Congrats, Dr. Taya.
Thank you.
Yeah.
I am from Canada, Alberta specifically.
Nice. So we have an international dig here, everybody. Yeah.
And so I originally met Denver through some research that we do. So I study tooth marks and tooth wear and tooth shape, that sort of stuff, which overlaps with some of the stuff that Denver does. Mm-hmm. We collaborated on a couple projects, and we got to talking, and I mentioned how I hadn't done any field work in the States, and he's like, oh, I've got a site that I work every summer. Why don't you come down? I was like, I would love to. So I've been coming here now, I guess this is my second year.
Nice.
And it's a really great crew, which is really nice, and it's a little bit different from the stuff we get in Canada, but not too different.
Huh.
it's really nice to have a site so close to where we park the truck.
Right.
too.
Yeah. Not a huge hike.
Yeah.
Yeah.
And it's like a gold mine too, so
Yeah.
that's an added bonus.
Awesome. Yeah. Can you talk a little bit about tooth marks from what? What kinds of critters we talking here?
So I think most of the tooth marks that we see on like hadrosaurs, so the duck-billed dinosaurs, and then the frilled ceratopsians, are probably made by tyrannosaurs, just because
Nice.
they have the big, robust teeth.
Yeah.
Maybe some crocs or something croc-like that.
Yeah.
But for the most part, I think our dromaeosaurs are not going to be leaving marks that we can really identify through
Gotcha.
the filter that is the preservation process.
Yeah.
Unfortunately, it kind of bangs up some of the bone surfaces and it makes it hard to tell what some things are.
Right. Yeah.
But the really noticeable tooth marks, I think, are all tyrannosaurs. So
Nice,
things like
cool.
T-Rex and Albertosaurus, for
Yeah,
example. So
Also, to bring things home for some of the long-term audience members, we discussed a paper a few months ago, maybe a year ago, about a tyrannosaur tooth embedded in the snout of a duckbill at Montosaurus. It's a Museum of the Rockies specimen. I'd actually shown it live on stream when we visited Museum of the Rockies years ago. Anyway, we were going over this paper. You're an author on the. Are you the lead author on that paper?
I am first author. Yes.
Holy cow, that's awesome! Yeah.
Yeah, one of my favorite specimens, actually.
Uh-huh.
We've got another one up in Canada that I'm currently working on,
Uh-huh.
and is hopefully getting ready to be submitted for description. So
Right.
stay tuned. But
So tell us why that's one of your favorite specimens. Let's talk about the significance for anybody who might be unaware.
it's just the story that it tells. So
Uh-huh.
with tooth marks, a lot of the time we can't really say if the animal was dead or alive
Uh-huh.
at the time that tooth mark was produced. Usually they don't show any signs of healing, so it's like, was it alive? Was it dead? We don't
Uh-huh.
know. And oftentimes it's really hard to tell exactly who made the tooth mark.
Right.
But the thing is, we had an embedded tooth, so we can look at the denticles on the
Yeah.
sides, right?
So you just have a smoking gun. It's like
yeah, exactly. That and making an identification. So we got all the way down to genus, which was fantastic.
nice.
And then you can analyze like the orientation of the bite too, because
Uh-huh.
the teeth are shaped a specific way.
Right.
So you could tell the bite was directed from the front. So that sort of, if you look at modern animals,
Uh-huh.
that's usually like a killing blow.
Right,
to get
yeah.
that, rather than like trying to pick something up and move it around to get
Uh-huh.
at a better bit.
Yeah.
So that was super fantastic. And honestly, I have not seen any other specimens that really tell that story
Right.
so convincingly.
So cool. Just a tyrannosaur coming up and biting a hadrosaur right on the face,
Yeah.
leaving a tooth embedded in the snout.
Exactly.
It's pretty awesome. Yeah.
Almost meme-like in some ways.
Yeah.
I don't know if you've seen that. What is that? That dog? The dog biting on the other dog's face.
Yeah, yeah.
It's almost like that.
Yeah.
Which was.
That's really
kinda funny. Yeah.
Cool. Yeah. Thanks, Taya. I'm sure we'll
Yeah,
be
no
back with
problem.
more questions later. But yeah, awesome. Appreciate it. Yeah. Yeah, and Sherlock Holmes paleontology. There it is. Sandwiches Breeze. I mean, yeah. Like it is kind of like detective work in a way. I know that's an overused cliche, but you know, there's a reason people say that. You know, we're trying to take bits of evidence and use it to tell a story and figure out what really happened. So it is like Sherlock Holmes, I suppose, but Sherlock Holmes was fictional, though. This is real. Scallywag Deep says, did T-Rex have feathers? So we don't know about Tyrannosaurus in particular, but we do know that other kinds of Tyrannosaur, other relatives, members of that same family, like Eutyrannus, did have feathers. We know that for a fact. We know that dinosaurs like Velociraptor had feathers all over their bodies. We know that for a fact. So, or at least, you know, we have strong evidence of that. We have quill knobs on the ulna of a Velociraptor. Those bumps that are consistent with the same bumps that we have on, say, so we do know that a lot of dinosaurs did have feathers, but we're not sure about T-Rex in particular. But if you're asking if dinosaurs were more similar to lizards or to birds, the answer is 100% birds. Birds literally are a kind of dinosaur. Birds evolved from dinosaurs that would have looked a lot like Velociraptor. So, yeah. Dinosaurs are a kind of reptile. But since birds are a kind of dinosaur, dinosaurs are reptiles. Birds are dinosaurs. Birds are reptiles. So, yeah. lizards are they're not particularly close to dinosaurs on the reptile family tree. Sure, they're diapsids, but they're not archosaurs. And so in many ways, lizards are a really kind of poor analogy for dinosaurs. There's fewer similarities than you might imagine. Really, birds and crocs, alligators, crocodiles, gharials, and their relatives today, they're, outside of birds, the closest thing we have to dinosaurs. So birds literally are dinosaurs. Crocs are like cousins to the dinosaurs. Those are the two groups that we often use as comparisons. Lizards they're not particularly close. So, does that make sense? Yeah. And that's very true, Mr. Annan to you. Yeah. Emus are living dinosaurs, it's true. Emus, cassowaries, ostriches. Those particular birds are often used as kind of a nice analogy for dinosaurs because they don't fly. As flightless birds, what we call ratites, the like larger flightless birds, ostriches, emus, rheas, cassowaries, tinamous. Are kiwis in there too? I think they are. Anyway, they're not adapted for flight. When you're a volant animal, an animal who's adapted to fly, there's all kinds of weird, crazy stuff that you have to do to your anatomy to maintain that flying ability. You lighten up your skeleton, you have specialized respiratory system, and just a million other things. So yeah, if we're just talking about a critter running around on the ground, like most non-bird dinosaurs, then like an emu is a really good analog for that. It's one of the best we've got. Yeah. And thank you, Charlie's Dragon. Yeah, kiwis too. Nice. But yeah. Good stuff. And Freelancer, yeah, we do have an excavator on site, which we're quite lucky to have here. For a limited time only, we've got large-scale mechanical help to remove some of this overburden. So all the stuff up here, this used to be like a high back wall. And there was all of this, what we call overburden up top. So it's just all of the rock that doesn't contain important fossils, at least not as far as we know. It's nice to be able to, you know, to have somebody with a bit more high-powered digging ability to help us out, so we don't have to move all that by hand. So that's literally saving us weeks of work, so that we can cut away with all of this stuff by hand. Like Laura's. How you doing, Laura?
Great.
Yeah. So some of you in the chat might remember Laura from yesterday, from the egg site. What have we got going on over here?
Under here. Well, Taya helped jacket it yesterday.
Nice.
So they're thinking it's possible pterosaur.
Ooh.
So we'll see.
Yeah.
When we get it back to the lab.
Possibly a vertebra in there?
Taya probably has a better answer than I do.
Yeah.
What was the question? Sorry.
What's under this?
Oh, it's possibly a centrum like from a pterosaur. It
Nice.
could also be like a limb bone from like a crocodile or something like that.
Okay.
Unfortunately, what you want to do in the field is just sort of expose a little bit of it,
Yep.
so that you can figure out where it is and then jacket it and then package it up and take it back to the lab where it can be exposed properly.
You do that safely, so yeah, they'll be a nice present for somebody to open back in the laboratory.
My
That'll
little
be really
bench
exciting.
here has all sorts of things.
Yeah.
There's something popping out over here.
Ooh, yeah. What is that? Interesting.
Denver said it may be a lump.
A lump. Okay.
That's a
We have
technical
a
term.
potential lump here.
Yeah.
Nice.
Oh, we've got something going on here. This might be just some wood overlying, but there's
Okay.
some more bone coming.
Ooh.
Another piece here.
Sorry to
and
make
a
you take all the foil off. We appreciate
no,
it.
it's okay. I
Yeah.
just try not to cover them up. And this one sounds to be the most entertaining. It's a little bit harder to see. Part of it we kind of glued that other edge back on, but you can see a bit of it here and a bit of it right here.
Yeah, some bone there.
Yes.
Very cool.
The two flat bits you can see are zygapophyses from the vertebra. So
Nice.
the little bits that latch onto the next vertebra.
Yeah. Are these post or pre-zigs, you think?
Probably pre-zigs, but
Nice.
it could be upside down.
Yeah.
So it's definitely a vertebra.
Uh-huh.
it's quite dense and it's got some loose space inside of it. So I'm inclined to think it's probably theropod.
Nice.
Not sure.
Be excited. Very cool. Yeah. So, as is a common theme here, the IDs we do in the field are often pretty preliminary. So we'll figure what these things are in the laboratory. But yeah. What are you hoping to find out here, Laura?
Oh, anything. Paleontology is not my background. I came out last year for the first time to check it out and loved it, and I'm back this year for a little bit.
Awesome. Yeah.
So yeah, I'm happy about finding anything from leaf prints to clams to any sort of dinosaur fossils. So
Nice.
I'm here for all of it.
That's a good answer. Yeah. Yeah. Thanks. Yeah. All right. John, can we put you on the spot for a minute? Yeah. How you doing over here?
Great. So I started here and I went through a plant layer, clam layer, and I'm trying to level it off over here as well. And I haven't quite hit the jackpot layer over here that we're finding a lot of amazing vertebrate fossils. But yeah, it's been really exciting. And I worked at the egg site earlier, but it's been amazing working here as well. It's my second day. So yeah.
Nice. All right. Cool. Thanks, John. Where are you from, by the way?
Milwaukee, Wisconsin.
Milwaukee. Any Wisconsinians, Wisconsinites? What do we call the good people of the Badger State? Badgers?
Well, no, more like Madison, Wisconsin, but like Wisconsinites is completely valid.
Wisconsinites?
Yeah,
Okay.
usually.
That's the proper demonym. Nice.
But yeah, I'm also a collections move tech for the geology collections at the Milwaukee Public Museum.
Nice.
So yeah, just a little background for me. But
Very cool. Yeah, famous for their pterosaurs mount. There was a crazy music video about that back in the day. Have you seen this?
I actually recorded it, so they actually had it, and they actually.
It's on YouTube too.
It is. But it's astounding, and it's a little bit of like paleomedia that is like forever preserved.
Yeah.
I don't believe they'll have that same video in the new museum, unfortunately.
Yeah.
But really. So yeah.
Fun stuff. I love the Milwaukee Public Museum. They're doing a huge renovation right now, and that'll be really exciting when it reopens. But yeah. Oh, and Packbacker says 414 checking in. Is that Wisconsin code right there? 414?
It is.
Nice.
So
I know, oh goodness, what was it? The area code for Madison area. 608 was the one that I knew. My girlfriend in college was from Dane County.
nice.
But 414 is Wisconsin, is Milwaukee?
It is.
Nice, yeah, very cool. Yeah. By the way, we've got Steve in the chat, checking in for civilization right now. And I think, is that Alessandro Chiarenza in there too? Alessandro, is that you? They said say hello to Denver. So, you have any messages for Steve or to Alessandro?
Steve, I'll see you for dinner later. Good to see you, Alessandro.
Yeah. Yeah. Awesome.
No, somewhere, I don't know, probably in Britain maybe, or somewhere else around the world.
Yeah.
Yeah.
Awesome. Yeah. Cool. Oh, and there goes Charlie before we can bug him.
There's a knot hole in a piece of wood.
Yeah?
It's quite nice.
Oh.
I mean,
Look at that. Wow.
you can genuinely see that it's a piece of wood with a knot hole in it.
Like 76 million years old.
Yeah.
Pretty
Not the
cool.
most thrilling thing ever, but
Well,
actually,
it's recognizable. People have seen wood before. So, like, oh yeah, I know that. Something recognizable.
that's the most exciting thing from my spot so far.
Yeah, well, maybe you'll find a primate skull or something. First one from the Campanian. But no, people think that's really cool, literally. They're like, oh wow, that's so cool. Yeah. Oh, and Tango Utah says, I went to UW-Madison. Go Badgers. Nice. Yeah. I did not go to that school, but I've been to that school. Got a lovely geological museum at UW. It's where Scott Hartman is, of skeletal drawing fame. Yeah, lovely institution. They've done a lot of work out here in Montana. So, yeah. And and Claire's got a question about the lithology at the site. You mentioned a channel lag. Does that make the rock here mudstone or sandstone or something more complex? So I would say this is kind of a, I don't know, it's sandy.
It's a muddy sandstone. I mean, it's mostly sandstone, but there are some like muddy interbeds. As you get higher up, you've got a bit more silt where we get the leaf bed.
Right, yeah.
Maybe someone will find a nice leaf that you can see.
I did have some fragments over there, but they probably faded. There were some leafy bits that I was trying to set aside. Well, you can see that one. Yeah, so I've got that central vein in the middle of a leaf right there.
That one's not bad.
So not as pretty as the stuff that I was showing you from the almond earlier this summer, but you know, see the veins in the leaf?
Some conifer twigs here.
Oh, that's cool.
There's a leaf.
Oh, that's a really pretty leaf compared to what I have.
There's a little leaf.
Yeah, look at those. Shoot. Those are great. Nice.
Yeah. And mostly up here. There's some a bit further down as well.
Yeah.
So,
oh yeah, thank you, John. Nice. Another leaf. Excellent. Appreciate it. Yeah.
yeah, it's mostly sandstone with some interbedded mudstones. The interesting thing about it is, like, the whole channel sandstone itself is about a meter thick, but it's got these gravelly layers, which are not as coarse as they look. You can see, you can see. Here's a bit where that wood came out.
Right.
These little pebbles, they're actually what we call intraformational mud clasts. So they're little lumps of mud that would have been from falling, collapsing riverbanks.
Okay.
So most of it's made of that. Though this is the good layer. When we start finding those little mud clasts, and that's when we slow down and take it really carefully, because that's where the fine stuff has been. At the very bottom, especially at the back end of the site, where you'll see more of our diggers in a minute. We've actually got more large bones. We have another hadrosaur coming out at this end, Gripposaurus. We managed to identify it last year because we found the brain case.
We've got two hadrosaurs in the same quarry.
Two large hadrosaurs. We have baby lambeosaurs as well.
Nice.
We have parts of a skull of one, and some limb bones.
Nice.
And then some mid-sized lambeosaurs as well. More skull material.
Nice.
Surprising amounts, actually.
Very cool. Oh, and we've got Paleo stream in chat. That's Joshua Knupe, paleo artist from Germany. He says hello.
Oh, hi. Yeah, I always loved his work. I see it on. I'm a follower on Twitter. So,
nice. Yeah. Really, really cool ecosystem reconstructions. Josh is really, really good at that. Awesome stuff. But yeah, excellent. And Murph is very excited to hear an English accent.
What remains of it? Yeah.
How long have you been in the U.S., Denver?
At this stint since 2007.
2007. So nearly 20 years at this point.
Yeah.
Wow. Okay.
Yeah, that's when I started my PhD.
Nice. Yeah. Which took about 10 years, but did about 10 times as much as many other PhDs that I've seen. So, how many more publications are coming out from that? I mean, Denver's up to his eyeballs in publications that he's working on.
It's like a big list of questions not to ask me.
I'm sorry. But this is real, unscripted.
When are you going to publish your dissertation? Well, my dissertation, I only have one paper left from it that hasn't been published.
Nice.
I think it's the best one. It's the very last chapter, and it's about the evolutionary forces that are actually driving evolution.
Like we were talking about earlier.
Yeah, the horns and crests of mostly ornithischian dinosaurs in North America. So I think it's one of my favorite ideas I've had. So I've got to get that one published. But otherwise, we have a lot of material, and I've got a paper with Taya on tooth marks, and paper with Danny on
Spinosaurs.
Spinosaurs.
We were saying we got to get that. I got to get that done. That's on me. Yeah.
So we got with Gabriel, who you probably met yesterday, I guess. We're working on a couple of papers describing things from here and from other places. So lots of different things. Yeah.
That's, I don't know. Denver's always got new things to work on, and I don't know. You've never been short of ideas. That's the thing. Like,
I really like the ideas papers. I mean, a lot of the descriptive work. I get students to work on those kinds of things. I like the ceratopsids, and occasionally I like weird little theropod things. But a lot of the descriptive work we give to people who come out and dig with us. We've got a few different projects with people who've been on our cruise, including the bird material that Lauren is describing. She was on our crew, I guess the year this was found. It might be that year, yeah.
Okay, nice. Yeah. Oh, Yash in the chat says, I can't wait to do a reconstruction of this fauna from this site.
Oh.
What would you really like to see that you think hasn't been portrayed enough in a reconstruction?
I love my Leptoceratops because they're ugly little pigs that live underground. I know Josh, you did a really nice painting of that a few years ago. I'm very, I don't know. I like seeing evolutionary hypotheses painted, like some of the research papers we've had done when we did the description of the Pentaceratops lineage.
Yeah, Navajo and Terminacavus?
Yeah.
Yeah.
The artwork done for that
Was it Bobby?
by Veal Sinkinen.
Oh, okay, nice, nice.
We drew,
Yeah.
I said this here and here, please, and he painted it. But it was showing the evolution of them as they go through time.
Yeah.
Which I found really helpful to illustrate the hypothesis.
That is a really cool illustration. That's honestly one of my favorites. I show that off all the time on stream. Yeah.
And last year, not here, but another site, we found a nice frontal from a big varanoid lizard.
Oh.
That's Paleosaniwa.
Yeah.
I was very taken with that because we'd found the vertebrae at a number of sites, really big lizard vertebrae.
Yeah.
I was very excited, and then I was collecting the last pieces of a really heavily tooth-marked bone that me and Taya are interested in, and right next to it was this little frontal bone from a Paleosaniwa, great big monitor lizard.
Yeah, kind of like a Komodo dragon, if you want to imagine that, Chad.
Yeah. This one would be a little bit smaller than a Komodo, but still would have probably eaten like baby dinosaurs and stuff.
Yeah.
So I was super excited about that.
That's really cool. Yeah.
That needs to be described as well. We get a mixture of like nice skeletons and fairly intact skulls, and then all sorts of interesting small pieces.
Right.
Some of those small pieces start coming together and you get more than one bit, but other times it's just like one or two bones.
Yeah. Cool. Awesome. Yeah. We might bug you in a little bit to ask about Dinosaur Park formation and all that, but for right now, let's continue on down the line and let's go bug Charlie. Charlie, what are you up to over here?
I found some sort of bone. I think it's carapace or ostra.
Cool. Some turtle?
I think so.
Nice.
You probably know better.
Let me take a look.
It doesn't look. It looks like.
Yeah,
bone.
it looks turtley.
Yeah, it looks a little bit more textured than bone. So
Nice.
it looks like the turtle I've seen. So yeah.
Cool.
It's taken a bit because you have to be careful.
Yeah. Oh,
And
awesome.
I feel like I bit more than I can chew because it keeps getting bigger. So that's not been fun. Actually, I'm pretty sure it's carapace because I can see the little edges here. Pretty confident in that.
Oh, Leatherback Siren in the chat says, just joined at the perfect time, turtle time. Oh yeah.
Hopefully.
Although this is a turtle with a hard shell, unlike a leatherback.
Yeah.
The only true soft-shelled turtle in the world. Trionychids are imposters. They have a hard shell underneath that soft, squishy. You know what I mean. But yeah. Anyway.
Yeah.
Very cool.
And I am using a toothbrush.
Nice.
It started as a bit.
Make sure you clean it before you brush your teeth. Or maybe not.
Yeah, did y'all meet Neo yesterday? Was Neo at the site yesterday, at the egg site?
He was, yeah.
Yeah, Neo, he said it as a bit because, like, we bought the toothbrushes. He's like, Charlie, you should use it. And I brought it as a bit, but it's actually really good. So.
It actually is really good, yeah. I've got a couple in my bag, too.
Yeah, like, obviously you have the
soft brushes?
Yeah, you have these brushes, but, like, these are really good when you, like, think you have a fossil.
Yeah.
And it ends up being a fossil. So it's really good for getting the really fine grains off.
Nice.
So that's pretty nice.
Yeah, very cool. Charlie, where are you from, by the way?
Grew up in Florida, live in Northern Virginia, go to school in DC.
Nice, okay. There you go.
Yeah.
Cool. Any Floridians, Virginians, or District of Columbians in the chat? Make some noise. But, yeah, awesome. I'm sure we'll come back in a bit, but good luck with Turtle Chunk there.
We'll see.
And, Got a question from Scallywag Deef. Teeth aren't bone, right? So, no, but also they've got some of the same underlying components. So, with teeth, you've got dentin and you've got enamel, but I think there might be some hydroxyapatite in there too, which is the stuff that mostly makes up bone. You know who we should ask about this is Taya. Yeah. Anywho. There. She's busy at the moment. But, here, Ed, can we bug you for a minute?
Sure.
How's it going, Ed?
Yeah, doing well.
Yeah.
Yeah.
Where are you from, Ed?
Actually, yesterday I said I was from Phoenix and Rockford, Illinois.
Yeah.
But I grew up in Milwaukee.
Oh,
so, yeah.
okay.
So, go Badgers.
Yeah.
Bucks,
I thought I
Brewers.
detected a little bit of Wisconsinite accent in there. So
Yep.
Nice. Yeah. How long have you been working with the crew?
I think this is my 3rd or 4th year here.
Nice, yeah.
It's always a great crew. Highly recommended. Yep.
Awesome. Yeah. And you find anything good today so far? kinda working down that
little, just a little limb bone, hollow though.
that's
so
intriguing.
yeah, so that
Nice.
was, but yeah, it was sort of shattered and only, it might only been an inch long. But,
Right. Yeah.
so it's from something small and
Intriguing if it's hollow. That's like could be theropod, could be bird, could be a few things, but always exciting when you find a hollow bone like that.
Yep.
Nice. Cool.
All right.
Who's scrambling for the foil? We have something cool going on?
We've got a very ugly bone that I'm taking out.
Yeah. Can we take a look?
Sure, I guess.
Yeah. Don't expect too much, chat, but you know.
With it, that's cool.
That's cool, but
Oh yeah, look at that. Is it a big
So-
phalanx or something?
probably, yeah.
Nice.
And if you look here,
Uh-huh.
there's actually something else poking out right where I'm trying to pedestal,
Oh, that's tricky.
which is like
Yeah.
the step right before you
Yeah.
make the jacket, right?
Uh-huh.
So this ugly thing is going to get tinfoil,
Okay.
and then I'm going to pop it out so it's out of my way so I can start
Right.
working more around this guy.
Uh-huh.
I'll probably take this jacket down to here.
Uh-huh.
That's traditionally what you should do, but because this bone's here, I'll probably make it more deep
Yeah.
and then probably wider.
Nice.
We'll see. It's always a constant game of reassessing
Of course,
what
yeah.
you're doing, and naturally there'll probably be something that pops up right in the back trench here.
Right in the trench, yeah.
Yeah.
So it goes. But that's really pretty. That if that is
Yeah,
a big
yeah.
phalanx, so it'd be a finger or toe bone, chat. For those of you not familiar with that term, but that's pretty. That's really nice.
Probably a hadrosaur.
Yeah.
So
Can we bug you for a second with a question from the
Yeah.
chat? So we had the question: are teeth bones?
no, they are not.
How are they constructed differently?
So bones typically have like two layers. You've got your sort of cortical bone layer, which is sort of like, if you think about like an M&M candy, it's the hard candy coating,
yeah.
and then you got the sort of your chocolatey or peanutty inside, which is your
Trabecular.
trabecular or cancellous
yeah.
bone.
Uh-huh.
Whereas teeth are made up of different materials entirely. So with teeth, you get your really hard enamel, and then underneath a really thin layer of enamel, you get your dentin, and then you have like a pulp cavity
Right. Yeah.
underneath. So it's like a triple layer.
Interesting.
The great thing with the enamel is you can actually look at the microscopic scratches on the surface of the tooth in the enamel, and sometimes in the dentine, and you can analyze like the orientation of those scratches and figure out how the jaw was opening and closing.
Cool.
What kind of things they're munching on, so whether it was really hard or really soft, that sort of thing.
Right.
So
you can learn a tremendous amount just by looking closely at the teeth. You know?
Yeah,
It's not just the shape, it's also there's so much more information in there.
oh yeah, and
Nice.
you can get down to, in some cases, like down to the species or genus. But most cases you can get up to at least the family level, so you can say it's a tyrannosaur or
Nice, yeah.
a ceratopsian. So,
Cool. Okay. Here, thinking of that with the dentin and the enamel and all of that, these are like thecodont teeth, so like teeth growing out of sockets.
yeah.
Would a tuatara have teeth, given that they're not like socketed? They're just kind of like projections from the jawbone, right?
I guess.
A hard and fast definition for a tooth that like...
I don't know. I think it's based on the that it's made out of.
Oh, okay, that makes sense. That makes sense. We'd have to check and see what tuatara teeth are made from. Yeah. Cool.
I know there's somebody that's been working on that at the U of A.
Neat, okay.
She just graduated too, so.
Congrats to her.
Yeah.
Nice. Yeah, cool. Thanks for asking.
Yeah,
Thanks
no
for
problem.
questions. Yeah. Good luck with the wrapping there.
Yeah.
Yeah. Nice. Well, I hope that answers your question, whoever that was. But, yeah. And, from Scallywag D, follow-up question. What is it in the bones that makes them not decompose like everything else? Well, bones will decompose like everything else if you give them long enough. When we're talking about taphonomy, when we're talking about, like, preservation and why certain things rot away and others don't, if you just leave bones on the surface of the prairie out here, they will crack and shatter under UV and sun and wind and rain and the elements like that. Bones will decompose, they'll break apart, they'll turn to dust, whatever. In order to get something fossilized, it needs to get buried. So we were talking a little bit about this with Steve yesterday and the day before at the other site. But, yeah, bones just tend to last longer than the rest of a carcass. So there's kind of like an interesting order of operations when we're talking about decomposition. And we could go into tremendous detail with this. There are people who spend their entire careers working on this kind of thing. But oftentimes, like when there's a carcass rotting on the landscape, often the first thing to go is the eyeballs, because they're soft and they're squishy and they're nutritious. So lots of scavengers want to eat those first. And then you get stuff like the innards. They'll decompose soon afterward. Oftentimes scavengers will come by and eat them. So I've seen carcasses of like cattle out on the prairie in North Dakota where they're just bones and skin. So you have like that cattle rawhide just over the surface of all the bones, but then all of the guts are gone and the meat and the flesh, it's just skin and bones. And sometimes we get dinosaur specimens like that, where like there was a dinosaur that was out on the landscape. Scavengers had come by and had their fill, eaten all the parts they wanted, the skin and the bones, and then that carcass later got buried, maybe after a seasonal flood or a landslide or who knows. Usually seasonal flood for something like that. And so you get bone with skin that had dried up in the sun, preserved over the top of it. And this seems to be particularly common for duckbill dinosaurs. Again, the next time we're over with Steve, we'll talk to him about this, because it's something that he's really interested in. But it's more common than people realize. There's a lot of crews who they've dug up a duckbill dinosaur and they didn't realize that it had skin, because they didn't know what they were looking at, and they just dig right through it and only collect the bones. I don't know how many times that's happened, but it's more than a few. So anyway, the bones are made of hydroxyapatite, which is already like a mineral. It tends to be more resilient than the rest of the body. So the bones are usually the last part to really decompose. And so that's the most common part that we get as fossils. Bones and teeth and claws. And actually, when we're talking about claws, we're talking about the bony core of the claw. So I guess we're still talking about bones. Occasionally, you do get the keratin preserved too over the claws. That's our fingernails are also made of keratin. Sometimes you get that keratin sheath preserved. It's not super common, but I've shown examples of this on stream before with the Utahraptor megablock out in Salt Lake City. There's some beautiful keratin sheaths over those claws that show you the size and shape of the claw while the animal was alive. Not just that bony core, but the full claw. It's really cool. So I hope that makes sense. Yeah. And let's see here. ArcGod162 asks, were ceratopsians or hadrosaurs the dominant herbivores of the Dinosaur Park formation? That sounds like a Denver question. We'll go ask him. Holy cow. Andrew, how are you doing? I'll go say hello to the crew for you. Over 100 Fahrenheit in St. George today. Oh boy. It's chilly enough here that most of us are wearing coats, including me. So it was cold and rainy this morning, and now it's windy and a little chilly, so I've still got my coat on. Yeah. Anyway, hope you're doing well, Andrew. Here's Denver over here. Andrew Milner says hello in the chat.
Oh, hello.
All the stars are here in the chat today. This is lovely. Yeah. He says it's 100 degrees in St. George right now. He's a little jealous of us. You were talking about this earlier too, like how being cold is a privilege when you're in the field.
Yeah, shivering is definitely a privilege. Today was one of those days just try and lock in your brain and then remember it.
Yeah.
In a few weeks' time when it's 100 plus.
There you go. Yeah. Think back to better times. But Andrew says, I'm happy. Lots of great fossils and donations lately in St. George. Excellent. That's good to hear.
Yeah, Liz will be here. Not tomorrow, but she gets in tomorrow night, so she'll be on the site soon.
Nice, that'd be cool. Yeah. Liz Friedman. Well, she was Liz Friedman. Now Liz Friedman Fowler. No, she was Liz Friedman Fowler at the time. She was director, wasn't she?
Yes.
Yeah. Director of the St. George Dinosaur Discovery Site Museum. So a small world in vertebrate paleontology. If anybody's watching in the chat and they're like, "Oh, this is cool, Dinosaur Dig." We keep getting paleontologists and other people in the world of fossil science showing up in the chat and saying hello, and we all know each other, so it's a small world, you know? Yeah. Good stuff. And Becca Paintmore says, do you guys photograph the stuff in situ before wrapping and lifting? Oftentimes we do. If it's a smaller element, then we often want to just get it out of the ground ASAP. So we'll just wrap it up. But if it's really pretty, or if the orientation of the element might be scientifically important, we'll photograph it. We might put it into a map, all of that. Kind of like you saw yesterday. We were talking about that with Steve. But at this site, we have so many little elements just coming out all the time. And we try and work pretty quickly here because there's a lot of work to be done. We try and get these things done as soon as we can. So oftentimes photographing things and mapping them, it just kind of slows everything down. And at this site, things are so jumbled up. It's a channel lag deposit, so we're not really finding things in articulation here for the most part. Everything's just a hodgepodge. It's all jumbled. So exactly where the different elements come from isn't really important. Not at this site. Yeah. And Pugga Wugga, let's see. Niches and ecosystems are very complex. That's true, yeah. And they shift over time. And in certain places, one critter might inhabit a different niche than it does in another ecosystem. Like, I don't know, a good example of that nowadays is here in North America. We used to have wolves all over the whole continent. And nowadays, wolves have been extirpated from most regions. People have killed them or driven them out, which I think is unfortunate. So now coyotes, who used to be like smaller generalist scavenger hunters, nowadays they are in many places getting bigger, and they're kind of taking on a similar kind of niche to what wolves inhabited before. So yeah, it's interesting how those things work. And this is all the complexity that we see around us today. These ecosystems back then would have been equally complex, but we have so much less information about these fossil ecosystems that trying to reconstruct food webs and figure out who's doing what in what ecosystem is tricky, you know? Like, when we have these environments that are dominated by dinosaurs, I don't know, I think about this a lot with like your big duckbills and ceratopsian dinosaurs, your duckbills and your horned dinosaurs. We think of them as being strict herbivores, in the same way that, like, I don't know, an elephant or a rhinoceros are strict herbivores today for the most part. But maybe they occasionally would have scavenged things. Maybe they're eating invertebrates. Maybe they're doing this and doing that. It's sometimes all too easy to fall into the trap of thinking of dinosaurs as being just like the mammals we see today. But in many cases, they would have been doing different things in their ecosystem. As animals who laid eggs, the young start off much smaller, so the whole structure of that ecosystem might be different. You might have one dinosaur occupying a bunch of different niches over its lifespan, whereas mammals don't do that today. Maybe we'll talk to Denver about that for a minute, because I feel like that's it's an important thing to consider. I know I'm always talking about that, but it's nice to hear that from somebody else too. And Mango Bay for Life says we have coyotes in downtown Orlando, Florida. It's bonkers. We get them in downtown San Francisco, where I'm from. They're all over the place. They've adapted to all kinds of different human-dominated environments. Coyotes are very adaptable critters. Yeah. And got the heavy movers? We do in Everwinter. We're very lucky to have some mechanical help to clear some of this overburden today. It's saving us literal weeks of work, like I said earlier. Here, Denver, can we bug you for a minute about how, I don't know, I bring this up on stream a lot, how dinosaur-dominated ecosystems might have been very different from the ones that we see today that are dominated by mammals. Like, we make assumptions sometimes, or it's easy to do that. Like, big herbivores, they're doing one thing, and, blah, blah, blah. But, like, animals that are moving through different niches through their lifespans, how do you think that might change the structure of these ecosystems? And how would we test that, too,
Well, I think fundamentally, the thing that changes the KT boundary for me is that you go into what I call an adult-only ecosystem.
Yeah.
And we actually present a little bit about how we think this affects the extinction of the KT boundary. Dinosaurs, because they hatched from eggs that were relatively small compared to the adults, had to go through so many different different size classes as they grew up.
Yeah.
They would have occupied different niches by virtue of their size alone. And eating different food and eating different quantities of food, needing different spaces for shelter, that kind of thing. Fundamentally, the ecosystems would have been, the majority of animals would have been young or immature. And it might be only the biggest ones that breed. So, how does that affect things? It means most of the things that we find fossils of, most of the dinosaurs we find fossils of, are probably not adults. Certainly, at least in the Triceratops that we've been collecting, most Triceratops that we find in the Hell Creek, 10 years ago, they're subadults, most of them. The really big adults are quite rare. And as we start to appreciate that more in all the other dinosaurs that we look at, you think every dinosaur that we have, chances are it's probably 3/4 grown at most.
Right.
Unless you've got a large sample of maybe 20 or more. It means that the picture that we're going to get from that is I'm not quite sure where I'm going.
It's kind of skewed, like...
Yeah, it's like, how would that change the way we do it?
Right. Interesting. It is interesting. We were talking about Nanotyrannus earlier today, and it appears the story there is not quite as clear. I guess the point that I'm making is this is a subject of ongoing work and discussion, and we're still figuring a lot of this stuff out. You would think these would be really basic questions for these ecosystems, like who's doing what, and what does the food web look like, and all of that, but it's still kind of, so much of this stuff is still unknown, Yeah.
Here's a totally different thing.
Yeah.
Look at these things of beauty.
Ooh.
So, we use a lot of different kinds of tools.
Yeah.
These are very specialist chisels. I don't know if Alessandro's still on, but look, Renzo Milani.
Oh, you know who is on right now is Filippo Bertozzo.
Oh.
He just joined us, yeah.
No, I have a whole bunch of different ones, but these are two of my favorites.
Nice.
So this one has a carbide in the tip, and then this one's called Fire Steel, and it's extremely slender. Now these are made for carving marble mostly. But,
wow.
So there's a lot of sculptors in Italy, or at least there's lots of people who make chisels for sculpting in Italy.
Interesting.
And there's nothing that compares to these. And you can get so many different ones. Like I don't know of anywhere else in the world that that makes them, certainly that makes them as good as this.
That's really cool.
And they're really...
Where'd you get them?
They're imported from Italy, but these come from a cellar in England. They're on the south coast of England because there's quite a lot of fossil collectors in England. So they make all these different ones. They make some for carving granite, some for carving marble, and they're just super precise. And this one I really like because it's so slender, like it's fire steel. So it's really, really strong steel, and it slides in between the layers and gives you a lot more control over how you break the rock. And then this one, I keep 2 of them handy, but I've got like 10 different ones.
Nice.
This one's more for like chipping off little bits of like harder rocks.
Gotcha. Yeah. Alessandro is still here in the chat, and he says, "I have a collection of these. I bring them with me to Mongolia."
I think there's one place in North America, it's like Pennsylvania, Forge, that makes really nice chisels. They're a lot more expensive because the Italians, I don't know, they just produce tons of these things and they're really, really good.
Nice.
They're not cheap, you know, these were like, I don't know, $50 each or more, but absolutely fantastic.
Awesome. I'm gonna get me some of those. Shoot.
Yeah.
I'm gonna have to ask you about where to acquire them. Nice. I feel like that'd be really useful for Utah. And Filippo says, Filippo is remarking about he says, Filippo is here. Oh, anyway, here are these. These are amazing.
Okay.
I think Filippo wants a proper greeting.
No. Hi, Filippo. We're trying to find some more duckbills.
Yeah, nice.
There should be more of the big one at the end here.
Yeah, and we've got the Liberty lambeosaur over there. I might be able to just get enough signal that we can peek over the edge and take a look at that if we want to do that at some point, Denver.
Yeah, we can do that at some point.
Yeah.
I mean, it looks like a jacket in a hole.
Yeah.
But,
Nice. Well, that'd be cool at least to show up. It's kind of a famous specimen nowadays. I the skull as a magnet at home, which you can get at the Badlands merch. Can we get a link to that in the chat? Because people might want that.
We're starting to get all kinds of new merch as well. Artwork done, 3D prints of the skulls of Sisyphus, the Spinosaurus wilsoni Tyrannosaur holotype.
Very cool.
We've almost got the next skull in that line. Holger, that one's almost ready as well.
Nice, very cool. Yeah. Awesome, yeah. It's like, you have to look over there, like, is it coming this way? Uh-oh.
Way to get gently crushed. Incredible difference it's made to this site.
I mean, seriously, that saved us weeks and weeks of work, literally. Maybe months.
Many months.
Yeah.
We did it by hand.
Shoot.
We used to do like a week or two's worth of overburden. We got away with not doing any last year because we had just enough exposed that we could get away with it. But the back wall was getting really steep, and we just needed to. It would have taken us probably a month to do a good overburden. This is supposed to be many years worth.
Nice. Okay. We had another question too, and I guess Denver's the person to ask, but I'm not sure if there's really a hard and fast answer. Were hadrosaurs or ceratopsids the dominant herbivores, whatever that means, of the dinosaur park formation?
Well, I think that ceratopsids and hadrosaurs probably lived in slightly different parts of the landscape. So back in my Hell Creek paper, I was noting about how in the Hell Creek at least we find Edmontosaurus, pretty much the only hadrosaur in the Hell Creek, and Triceratops in different proportions depending on what type of rock we're in. Now,
it's like sandstone versus mudstone?
the sandstone versus mudstone thing was something that was brought up in a paper by Nick Longrich and
I remember that,
years ago. And I felt that was a quite literal interpretation, that they were suggesting that ceratopsians lived out in the floodplains and the hadrosaurs lived near the channels where the sandstones are. What I think is more likely is that most of the channel deposits that we find are actually deposited when the floodplain was well drained, and it's just the way that stratigraphy works.
Okay.
And most of the mudstones in the Hell Creek, especially at the top of the Hell Creek, when we get loads of Triceratops, were deposited when water tables.
Gotcha.
It was a much swampier environment. if you were in the period when sea level was rising, I bet you there were loads of ceratopsids all over these swampy floodplains. But if it was a period when sea level was falling, it was probably a bit better drained, a little harder underfoot. There were probably more duckbills.
Yeah.
And that would be what it would be in the Hell Creek. There's a few more species. It's a bit more diverse in this time period. But I'll bet you the same thing kind of holds true. That you see sort of swamp-dominated Centrosaur, Chasmosaur dominance, and then if it's better drained, more hadrosaurs, more ankylosaurs. One interesting thing about this coulee, and in fact the same is true in Canada, is in the Old Man Formation, or in the lower part here, the Judith River Formation, we get a lot more ankylosaur teeth than you'd expect. Like they're usually quite rare, and it's absolutely full of them lower down. They're one of the most common, if not the most common.
Weird. Yeah.
Suggesting, I think that it means that ankylosaurs like it well drained, which might make sense. You know, they're big, stocky animals. They probably didn't cope so well in muddy conditions.
Interesting.
I think they're stomping around when it's nice and well drained. It's still rivers and things. It's not drained.
For sure. Yeah.
But that's my sort of.
Interesting. I like that a lot. Yeah. Thanks, Denver. Cool. Yeah. Neat. It's cool the sorts of inferences that you can start to make when you spend a lot of time doing field work in this area, and I don't know, the more outcrop that you see and the more fossils that you find, you start to develop kind of a sense, a feeling for what's going on, and that's one of the things I've always really, really admired about people like Denver, is they've spent decades in the field, every summer, going out finding fossils, and you get a lot of perspective from that you can't get just from looking through the collections in a museum. You need that kind of boots on the to really be able to, you know, if that makes sense. Yeah. Anywho, let me scroll through the chat, see what I've missed here. As fun as it sounded. There you go, Filippo, yeah. Oh, and which were more plentiful, Raptor VT? Hadrosaurs versus ceratopsids? It depends what strata you're looking in, is what Denver was saying. Like, what we're seeing here in the fossil record is going to be... There's bias, you know? We're not getting a perfect snapshot of all the different critters that lived in this environment. And part of that is just preservational, like, you know, you're not going to find a lot of worm fossils or slug fossils because, well, they just don't really have hard parts like that. And so they're, yeah. That's a very basic, like, obvious kind of preservational bias. But at the same time, you're going to get different kinds of critters deposited in different kinds of rocks, and that doesn't necessarily reflect how common these animals were on the landscape. It's just, well, in sandstone deposits, you might find more ceratopsids, or you might find more hadrosaurs, versus in mudstones, you might find more ceratopsids. Just because, well, these rocks happen to represent a floodplain versus a lake, and you've got different kinds of critters hanging out in specific parts of the environment. So yeah, I don't know, there's some complexity there that I think is really interesting. Anywho. Yeah. And isn't it cool to see heavy equipment here? We're very lucky, Link for real. Again, this is not typical. We lucked out. Yeah. And Paleostream says there are a few modern day groups that have no fossil record at all. Oh yeah, yeah. And there's a lot of groups that are only known from traces. Like, well, worms are a good example. Where, like, we might have worm burrows that show that there were worms in that environment. Or there's a lot of insects like this too, where their entire record going back to the Cretaceous or the Jurassic is just based on the leaf damage. So, like, when these critters were eating leaves, you know, they make characteristic little marks on there. And that's the only evidence that we have for the presence of these animals in the fossil record. We have no body fossils from them. Like, we don't. All we have are the bite marks that they left on leaves, and we can match that to those insects today, to the bite marks that they make, and it looks exactly the same. So we know that those critters were around 80 million years ago or more. The idea of bias in the fossil record is, I feel like it's something it does get discussed, but I feel like it often gets kind of glazed over. You know, people kind of breeze past it. Like when you're learning about this sort of thing in a university class, like, oh yeah, the fossil record is very incomplete and very biased, but the details there are what's important and interesting. And I think some people take it to be like, oh, well, the fossil record, you can't trust it because, it's missing important stuff. That's not what that means. The fossil record can be extraordinarily complete in a lot of areas if you know how to read it. And if you do your excavations properly. It's just, know that there will be certain things that just don't fossilize well. You might still be able to find evidence of them, but you gotta try really hard. It doesn't mean that the fossil record is unreliable. It just means that you have to be smart about how you study it, if that makes sense. So yeah. Anywho. You brought these. Andrew says dinosaurs had no fossil record until we found them at the Burgess Shale. That's 520 million years or thereabouts. That's nuts. Yeah. Hang on. Dinosaurs. Are they cnidarians? Dinosaurs. Are they like salps or comb jellies or something? Dinosaurs. Somebody look that up for me. What are those? Oh, comb jellies. Excellent. Yeah. Thank you, Andrew. Yeah. One of the many soft-bodied organisms that leatherback turtles eat. Shout out Dermachelys coriacea. Where did I put that? I guess it's way over here. I should drink some water anyway. It's on my water bottle. Yeah. Shout out leatherbacks. I've been obsessed with these animals for the past year. Anybody who's been watching for more than a month knows about these critters, so I won't belabor the point. But yeah, holy cow, cool critters. How are we doing on battery, by the way? 45%. Okay, not too bad. Not getting a lot of sunlight right now. Only 2 watts coming in, 18 going out. This will last us for a while, though. Of course, I'm broadcasting to you live via satellite. So we're lucky we can do this because we're kind of out in the middle of nowhere. And I say that in the kindest possible way. This is a lovely place to be. And, oh, this is funny, yeah. So we're working here with the Badlands Dinosaur Museum crew, led by Dr. Denver Fowler. But we've got another Museum of the Rockies alum right here across the valley. Here's Denver over there, who did his PhD at Montana State. The now Dr. Kerry Woodruff did his master's degree at Montana State at the same time, and he is right over there. That's his truck across the coulee. Small world, you know? Kerry Woodruff is now at the Frost Science Museum in Miami, Florida. He's come all the way out here to do field work. So there's, I don't know if you can see it, but it's right on the horizon. See the little bump sticking up? That's Kerry's truck over there. One of these days, we'll meet up and camp and, you know, reminisce and drink beers and all that good stuff, but he's hard at work over there with his crew. And we're over here. I interviewed Kerry Woodruff, was it back in November, I think? Maybe late October last year? It was the first in our Fossil Finders SVP interview series. Dr. Carrie Woodruff is one of the world experts on sauropod dinosaurs. And on pachycephalosaurs too, I guess. That's what he did his doctorate on. But sauropods are Carrie's first love, the critters he adores the most. Those long-necked plant eaters. But yeah. Archigod says, I love Carrie Woodruff's work on sauropods. He's right over there. There he is. Everybody wave to Carrie. Yeah. Good stuff. Yeah. And Steve says, at least Carrie's truck didn't dissolve away in the rain. Thank goodness. Yeah, although don't jinx it. I don't know. Yeah. Let me catch up to the chat. Top Trike been here 2 years. Very nice, Top Trike. It's been wonderful having you here. And Carrie is there too. Yeah, he's not working with us, but we can see him on the horizon. It's funny. I need to update that books command too, because that's old now. I'm still reading those books, but I've moved on to 2 other books. I'm in the middle of like 4 books right now. Yeah. Dig sites passing in the night. There you go, Claire Burr. I was trying to remember the other day. There was a term for when sailing ships would meet up in the middle of the ocean, and the crews would like have a little party and exchange mail and stuff like that. It's in Moby Dick. Melville wrote about it, and I think it's called a gam. I'm gonna look this up real quick. And actually, Claire, yeah, if you could slow down its posting, that would be nice. But let me look this up real quick. Is that correct? Am I remembering correctly? Places, science and technology. Yeah, GAM, nautical term. There you go. To describe one whaling ship paying a social visit to another at sea. Yeah. Sometimes we have that out in the field. Nobody calls it that, but it reminded me of that term from Moby Dick. But yeah, it's always fun when like another field crew comes to visit. We used to get that a lot down in Jordan, Montana, which is near the type section of the Hell Creek Formation. So we'd be, in town, going to Fellman's Diner or whatever, Fellman's convenience store, and we'd run into a crew from the University of Washington, or a crew from whatever, and yeah, all just talk to each other. What we're doing, what have you found? Do you guys need anything? That's always fun, And it's weird because you'd be in these remote places out in the middle of nowhere, and then you run into a colleague that you see at scientific conferences or somebody you went to school with or whatever. It's funny how that works. And Gary Ankela says, do you have like a paleo network that do you know where different folks are excavating stuff? No, there's nothing like that. You just kind of hear things through the grapevine, and then I don't know, we've got people on the crew here who they're going to be working with other crews throughout the summer. So somebody new shows up to camp and be like, oh, well, how are things down there in Wyoming? Or what's going on up in Alberta and all that stuff. So there's always a lot of that. It's been fun telling stories from just last week in Wyoming to this crew. They were really interested to hear about the ceratopsid that we were digging up there, which we're very excited about. All kinds of stuff like that. So, yeah, it's a small world, the world of fossil science. And, yeah, it's cool. You can tell that just here in the chat. We've got several PhD paleontologists and museum curators and folks like that trickling in and trickling out of the chat. Yeah, the social network is small but close-knit, and we mostly get along with each other, mostly. And thank you, Claire, I appreciate that. Yeah. And Yash is totally correct. Some people don't want to tell where they dig. And in some cases, it's better not to tell people. Poachers have ears everywhere. That's true. Yeah, so like when I work in Wyoming, I try and be a little cagey about where exactly we're working because we don't want fossil poachers showing up. Eventually, you have to say where you're at. If you're publishing papers, you have to be able to say where your site is. But different journals have, different editors and peer reviewers have got kind of different ideas about this. Sometimes you have to be super specific, sometimes you don't. But yeah, but Josh makes a good point there, for sure. Yeah. Anyhow. Yeah. So I can say here, we're near the town of Havre, Montana, but that's a big area, and well, yeah. There's also commercial groups who work around here too. There's, you know, there's a lot of private land in this area. So people who, you know, they're not digging up dinosaurs for science, they're digging up dinosaurs to make money. There's a lot of them who work around here, and they've, as I've heard it, destroyed a lot of specimens because, you know, they'll do something like this where they'll bring in a tractor and they'll just dig straight through the bone layer. And then they look through the rubble pile and just sell bits and pieces of crocs and dinosaur bone and stuff like that. But they don't know. They could be digging through a beautiful, complete skeleton and they wouldn't know it. So that's very much not what we're doing here. So yeah. And that is an excavator, Ms. Blue Skies. Yeah. Yeah. Clearing away some of the overburden. So we've got a lot of non-productive rock here, stuff that the fossils are not coming out of. We need to be able to dig through that in order to be able to extend the productive stuff back and find more and more things. So, as Denver was saying, that machine right there is saving us literal months of hard labor, and we're very lucky to have that kind of help. So I know this is unusual to show on stream, and I'm always talking about how we usually don't use heavy equipment at dig sites. This is an exception, and again, we're very lucky to have it. And what kind of overburden is it? Recent stuff? Or... Oh no, so the overburden here is also Judith River Formation. Although, word on the street here is it should actually be Dinosaur Park Formation, even though we're south of the border in Montana, because the fauna here is much more consistent with Dinosaur Park than it is with Judith. But I'll let Denver talk about that in a little bit. Anyway, it's just a bunch of overlying rock that it's not been yielding anything. And so the crew in previous years has worked all this down by, you know, with picks and shovels and not found anything. And so I guess Denver felt it was safe to be able to bring in a big excavator and just dig through it quickly. There's limited time and limited budget for this kind of work, so this is, holy cow, is it kind of a godsend. This is going to allow us to find so many more fossils, not having to deal with all that overburden by hand, you know? Yeah. And you were correct, PaleoStream, but yeah. I don't know how that made it through the auto mod, but yeah. Sorry. We do have a rather strict no cussing policy on this channel. I'm not sure how that made it through, but anyway, Josh, I appreciate you. Yeah. Anywho. But it's funny how, like, I don't know, sometimes the geological formations, they vary country to country, even though the rocks don't really vary. So that's one of the things that that Denver is hopefully going to be publishing on, not before too long. He talked about him and Jack Wilson got a paper about this. The mature lands, exactly, PaleoStream, no worries. Yeah. Oh, VIPs are exempt from filters? Is that the case? Oh, okay. Interesting. Anyway, we've got 420 people watching right now. I might as well do a quick channel break, or station break, like they do on the radio. Welcome to Paleontologizing, everybody. We're digging out here in northern Montana in the late Cretaceous Judith River Formation, or is it the Dinosaur Park Formation? We're here at the Jack's Bone Bed site, digging up everything from duck-billed dinosaurs to horned dinosaurs to raptor dinosaurs, dromaeosaurs, troodontids, ornithomimosaurs, crocs, turtles. Some mammals have come from this site, even some pterosaurs, which is very exciting. Pterosaurs tend to be very, very rare in the late Cretaceous of North America. Denver was saying we've got maybe the most complete pterosaur from Montana. It's come from this very site. Bits and pieces of it all over the place. This is one of those sites where most of the things are all jumbled up. Although, here, I can show you briefly. Over the ridge, we've got a Lambeosaurus, a fairly well-known specimen now. Liberty the Lambeosaurus was the nickname. That's from right over here. Let's take a look at that. Trying to stay in direct sight of the satellite dish. But there it is right there, underneath the tarps. Post-cranium from a Lambeosaurus down there. Just, they're waiting on, well, Liz is going to get here and some other volunteers are going to get here. They're going to continue working on that and hopefully get that back to North Dakota into the laboratory. So yeah, big old dinosaur. That's about the size of a car right there. Yeah. It's a big critter. So it's not all isolated pieces here. There's associated skeletons too. This is a really cool site. I hope you're getting a sense for that. And it's this site, exactly, Josh. Yeah. Good stuff. Here, let's check in with the crew and see if they found anything else right now. Let's see. Anything more cool coming out over here? Oh yeah. Nice, okay.
It's just
doesn't quite look like a centrum. I'd say, yeah, probably phalanx.
Yeah.
Nice.
So we've had some ceratopsid, I think 1 or 2 ceratopsid limb bones, and we had a nose horn, an unfused nose horn from a Styracosaurus.
So unfused, probably from a juvenile, right?
Yeah.
Nice.
So
let's get some Styracosaurus emotes going in the chat. I know we have those.
Could be a little toe by the looks of it, I think. Little hadrosaur, or it could be a ceratopsian toe. I mean, it would be the right size for the little ceratopsid, but I mean, I don't know quite yet, you know. Obviously,
sure.
We've got to get it all clean. Yeah. Some glue in a minute, but it's getting down to the same layer that Laura's getting a bunch of good stuff at with these few more clams.
Yeah, the white clam there.
It tends to be a good indication that there's more stuff. Like I say, it's the number of skeletons coming out, but they're all very scattered. They tend to be better at this end of the quarry for the lighter stuff, and then the heavier, larger elements at the other end of the quarry. But we've had these medium-sized ceratopsids and medium-sized duckbills throughout as well. So it looks like a nice little phalanx.
Nice. Let me put the camera a little closer if that's okay.
Get out of the way if you want to get in here.
There we go. Nice. Yeah. Very cool. Awesome. Yeah. Neat stuff. Here, let me go get a visual aid and I'll show everybody. Well, we already have the emotes there. Styracosaurus. Excellent. Denver, did I tell you we've got a Navajo Ceratops emote too? Yeah. So if you look there, you'll see the Styracosaurus. I did ceratopsid bodies, and then there's different heads, so people could do like a multi-part emote.
Oh.
Here, give us some Navajo Ceratops, chat. Yeah, there we go, with the orange. or kind of like reddish frill.
Oh, okay.
Yeah.
I can't focus that close very well.
But yeah, that's one of Denver's dinosaurs. When did you publish Navajoceratops?
2020, I think.
Nice, okay.
Maybe 2021.
Yeah.
Yep. Still have to do some follow-up papers to that.
Yeah.
Like one sorting out Pentaceratops and what it really means.
Uh-huh.
Another one describing Daniceratops.
Nice. Oh, that's one that I found in 2012. Really excited about that. Yeah.
That's a really important one. The oldest chasmosaur from North America.
Nice.
Probably.
Yeah.
At least thereabouts.
Uh-huh. Yeah. Thanks, Denver. Yeah, that's a common question that I get is like, what's the coolest thing I've ever found? Or, you know, what's a new dinosaur that I've discovered? Daniceratops is not the name of the dinosaur, it's the name of the site. But we were a few miles west of here, and back in 2012 I was out prospecting with Denver, and I found a new species of horned dinosaur. And yeah, Denver's been kind of sitting on that ever since. He's got so many different projects and different papers to write and everything else. You know, it's not been a super high priority, but one of these days he's going to get that published, and I will be very proud. A dinosaur that I discovered in the field. Brand new species. Pretty excited about that. So, anyway. And so, again, Ms. Blue Skies, to be clear, Daniceratops is not the name of the dinosaur, it's the name of the site. So it's a ceratopsid, like Triceratops or like Styracosaurus. And when I found it, generally the rule is, on crews like this, if you're out prospecting and you find a site, you get to name it. I couldn't come up with a name fast enough. I'd called Denver over and I said, look at this, I think it's either a turtle or an ilium from something, or it could be a ceratopsid frill. It was a ceratopsid frill. That was exactly what he wanted to find that summer, and I found it. So he was there, and he's got his notebook out, and he's taking a GPS reading and writing everything down. He says, Danny, what's the name of the site? And I go, and Denver just goes, Daniceratops. So that's what it is. That's the name of the site. He'll be naming the new dinosaur, and it's not going to be called Daniceratops. But he'll come up with a good name for it, I think. Yeah. Anywho. And Prince Nernerdus says, do we think adult ceratopsians huddled in a circle with their horns facing outward to protect their young huddled in the middle? We're not sure. You know, that sort of a hypothesis is difficult to test, you know? How do you prove or disprove a complex behavior like that? It's tricky. We know that modern animals like musk ox will do that. If there's some wolves that approach them and they're after their babies, the musk ox will all form a circle with their horns pointing outward and with the babies in the middle of the circle. In order for ceratopsid dinosaurs to do that, they would A, have to live in a social group, and B, the young would have to be part of that social group, to have to be with their parents or with other members of the herd, and we don't necessarily know that that's true. Especially not for all different kinds of ceratopsids. It's a big group of dinosaurs. There's a lot of genera and a lot of species, and different ones would have behaved differently, probably had different social structures. Is there any kind of ceratopsid that probably did that? Were there any horned dinosaurs that did the whole phalanx thing around their young? But science is unlikely. So I don't know. That's one of the things that'll probably remain in the realm of speculation, if that makes sense. Yeah. And we're back? Okay. Yeah. And lost the signal? Oh, not sure what happened. Could have been some people standing in front of the dish. Sorry. Anyway, I was saying that science is about testing ideas, you know? come up with a cool story that might sound plausible, but that's not science. Science is about using evidence to run tests and try and falsify or validate ideas with that evidence. That's what we're trying to do out here, you know? We might have a hunch about what this ancient environment was like, what kind of critters lived here, but by digging into the rocks and finding those fossils, we're testing those ideas. That's what science is all about. Yeah. And I saw Denver using a brush there, says Ms. Blue Skies. When you use fine tools... Hang on. Chat's moving too fast. When do you use fine tools and brushes in the field? So that's always a balancing act, you know? When you clean away all the rock from on top of a fossil in the field, we call that field prepping, and it's often frowned upon. You know, you want some surrounding rock around a thing so it doesn't crumble in the field. But at the same time, you have to find the full extent of it before you can put a jacket around it. So different crew members and different crews will have different philosophies about this kind of thing. If it's a really small fossil, I'm of the opinion that, like, well, only remove is the minimum amount of rock that you need to in order to safely figure out the silhouette, you know, the full extent of it, and then you put a protective jacket around it. But some of these things just pop right out, and you could just collect them with foil. Again, there's no hard and fast set of rules. It's going to change situation to situation. Yeah. And let's see. And call me Ollie? No. So here, I think you're getting tripped up on two different things. We don't know that dinosaurs exhibited that behavior. We don't know that. Just because modern, say, musk ox do that, doesn't mean that dinosaurs did, and they're not related to dinosaurs. Musk ox are a kind of mammal. Dinosaurs are a kind of reptile. They diverged a super long time ago, so they're not close relatives at all, you know? Like, musk ox are much more closely related to you and me as mammals than they are to dinosaurs. Does that make sense? Yeah. And Crimson says, besides those Centrosaurus and Pachyrhinosaurs who died en masse, do you have much evidence of other ceratopsians that could indicate they lived in groups? Let's see. Centrosaurus, Pachyrhinosaurus have both been found in mass death assemblages. I want to say that we also have that for some other ceratopsids. We might have that for... I'm trying to think. I want to say they have some chasmosaurs down in Utah that also maybe died in a group. We'll ask Denver maybe. But yeah. Anywho. And thank you, Prince Nerda. I appreciate the kind words.
Again, I'm still
Yeah. Oh, Denver is consulting. Have you right now? Oh, you got a tooth?
Yeah.
Ooh. Person to find a tooth too.
Yeah.
Oh, gorgeous.
Yeah.
Look at that. Very nice. Wow, excellent. What do you think it's from? I almost see is that a carina right there?
Yeah, so I think this is probably one of the anterior teeth from a croc.
Oh, awesome.
Yeah, so they tend to get kind of coney shapes,
Yeah.
really pointy and sharp.
Do we have Alexander Morrison in the chat right now? He loves crocs. One of my viewers is just
Yeah, yeah.
obsessed with crocodiliformes.
We actually got more than just the crown too, so we got part of the root.
Nice.
You can see right here this color change.
Yeah.
So that's what what would be sticking up out of the jaw, and then this stuff down here would be the part that would go into the jaw.
Nice. So that's there in the socket?
Yeah.
The kind of lighter brown.
This part right here would be
Nice,
in
yeah.
the socket. And then
Very
this
cool.
would stick out.
Awesome.
Yeah. Tooth actually that I found.
Nice, a batoid.
Yeah. Where did it go?
Maladaptus.
Wasn't
We often
that
called
chunk?
these rays, but they might be more similar to like guitar fish.
Yeah.
Yeah.
See if I can't find the little crumbly bits for you. But we got some gastropods. Some nice
neat, yeah.
little cross-section things.
Inverts, yeah, nice.
I set it up on the shelf too.
There's all kinds of shells over here. Look at all those. Yeah, a whole pavement of gastropod. Other mollusk shells.
Ah, there it is.
Oh, cool.
So that's the Maladaptus tooth.
Very nice, yeah. Shoot, I might go grab a magnifying glass real quick and bring it over to show everybody. I've got one special for the camera.
Oh, perfect.
Yeah, let me go get
Yeah,
that.
we're
I'll
gonna
be right
need
back.
that.
Yeah. Nice, thanks, Tim.
Yeah.
Very cool. Let me go grab that magnifying glass. I should have it on my person. It's over my water bottle holder. Let me grab it. But Maladaptus is, it's often portrayed as like a stingray, but it might be more closely related, or at least more similar in shape to something like a guitar fish. That's actually why I 3D printed that guitar fish about a month ago. Shoot, was it only that long ago? It's just 3 weeks ago. I was in Florida. But yeah, really cool critter. Here's the magnifying glass. All right, we'll give that a shot. There we go. For your viewing pleasure at home. Magnifying glass. Very nice, yeah. So they're almost like hexagonal or octagonal in shape, almost like a stop sign or something.
Yep.
Really cool.
And this upper part right here that you can probably see in the camera is the grinding surface. So
Right, nice.
they'd use that probably to crush up little clams and stuff like
Right, and then we've got the root underneath, which is kind of like, is it split like they often are?
that. Yeah. Let's see if we can get that.
There we go, yeah. So you see that like crease in between? Very cool.
Yeah.
Yeah.
It's a nice little one.
Thank you, Dr. Tay.
No problem.
Very cool. Nice.
Now let's get a little.
Yeah, well, actually, this is a nice opportunity. Let me show you that diagram with the different critters from this ecosystem. It's the same one I've been showing when we were down in Wyoming, but it actually fits a little bit better for up here, because up here we get champsosaurs, whereas down there we don't. But let me get that. There we go, right on top. Beautiful. Yeah. Nice. Actually, let's bring this over because I think Laura might appreciate seeing this too. You seen this diagram yet?
No,
Yeah.
not yet.
This might make things a little bit more real for you.
Cool.
Actually, if you could hold that well.
Yeah.
So yeah, Maladaptus. That's our critter might look more like a guitar fish than this. Here it's portrayed like a stingray.
Yeah.
But yeah, Lepisosteus, that's our gar fish. Have we had any gar scales from the site so far?
I haven't seen any. Have you seen a couple?
A couple?
Teas?
Okay. Weird, often they're more common. Yeah. There's a champsosaur right there.
Yeah.
Which, it looks like a croc here, but they're probably more closely related to lizards. They're kind of mysterious, the Caristodires. They're weird critters. Got a bowfin right
Here's
here.
one. I got a scale.
You got a gar scale?
Awesome.
Right on.
Speak of the devil.
Everybody gather around
Nice,
so that
yeah.
we don't have the wind blow it away. Let's see if we can get that in
Oh
there.
yeah, nice. So yeah, kind of arrowhead shaped, glossy. So that's made of bone and then a material called ganoid. They're also called ganoid scales. But gar are really cool because they're still around today. You can find them in places like the Louisiana Bayou. They're all over Florida. There's a unique species of gar that lives in Cuba called the Cuban gar. Not Cuban cigar, just Cuban gar.
Ganoid scales are only found in like basal fish, right?
I think so, yeah.
Okay.
Yeah, so they're also in like what we used to call Lepidotes. What's the group called? Gosh darn it. Jim Kirkland, if he's watching right now, he's shouting at the screen. But the fish with the bony scales, like Lepidotes and Sheenstia and stuff. Sturgeon have they've got similar osteoderms. Well, I don't know how similar they are, but like sturgeon are even more primitive. They're even more early divergent, along with paddlefish. Huh?
Bowfin?
No, what's Lepidotes? What group of fish is that? Lepidotes and Sheenstia are the oh goodness. They go extinct in the Middle Cretaceous. Lepidotits,
That's
yeah.
what I used to say.
Yeah, gosh darn it.
I know what you mean.
Yeah, it's gonna bug me. Oh, there we go. Thank you, Andrew Milner. The semionotids.
Ah, yes, yes.
Yeah. So the semionotids also have those bony scales like gar.
Okay.
Yeah. So yeah, it's a pretty nice
Yeah, that's awesome.
diagram. There's a hadrosaur. There's our trionychid turtle, soft shell. Scap herpeton. I always thought it was a fun one to say. It's a kind of amphibian. Yeah, cool stuff.
Awesome. Yeah, that's great.
Yeah, thanks.
Thank you.
Yeah. So, this has been a really useful diagram this year. I'm really glad I printed this. But lovely art by Russell Hawley of the Tate Geological Museum in Casper, Wyoming. He does excellent work. It's good stuff. Yeah. And there you go, Sharky. Yeah, alligator gar is Atractosteus. I don't think we have that particular genus from the Cretaceous, but Lepisosteus, what you see right there, we have this same genus today, and we have it from the late Cretaceous period. So oftentimes when we find those scales, we'll say, yeah, they're Lepisosteus SP period, meaning like some species of Lepisosteus, probably. It's cool how slowly those critters evolve. You know, and a couple years ago I would have said, no, they don't actually evolve slowly, that's a myth. But no, there have been studies that actually show that their rate of evolution, very, very slow. They happen to have, if I remember correctly, a very, very large genome. So they've just got tons of DNA, and their mutation rate is very slow. So when they reproduce, they do a very, very good job of like copying their genes to the next generation. And so you don't have a lot of mutations, so you don't have a lot of evolution. It's probably part of the reason why they've managed to persist for so very long in this, well, that's a no-duh kind of thing. They've managed to persist for a long time without changing much. They've got a very slow rate of evolution. The Lepisosteid fishes, the gar, they're really cool. Yeah. Anywho, yeah. And let me catch. I'm trying to hold this without it blowing away. Digital microscope at home too. But yeah. And the bowfin, yeah. Well, I don't know if we get a lot of bowfin here. That was the star of the show at Turtle Hill in Wyoming a couple weeks ago. Melvius is the genus name. We call him Melvin. We just get tons and tons of pieces of that critter. It's the bowfin is right here. This is genus Cyclurus. Ours in Wyoming is called Melvius. Yeah, it's big. It's way bigger than shown here. That critter's like maybe 3 meters long, like approaching 10 feet. Huge freshwater fish. I don't know if we get any of those here. I should ask Denver. But yeah, good stuff. Hey Denver, do we get any Melvius here? The amiids, the bowfin?
You do. I don't know if there's been any at this specific site. I feel like that. I'd have to think.
Yeah.
I think a few vertebrae.
Nice. Okay. The verts are pretty distinctive. Yeah.
Oh yeah. The vertebrae distinctive.
Yeah.
Some jaws.
Nice.
They're not super abundant.
Yeah.
They're not super huge.
We've got a huge one at the Turtle Hill site in Wyoming. We're thinking like 3 meters long. Might even be a new species, we're not sure. But that's like the star of the show. They're the verts. It might just be one individual that blew up. But there's just tons of skull pieces and verts everywhere.
They get really big.
Yeah.
In parts of the Hell Creek in North Dakota and eastern Montana.
Uh-huh.
They were never that big where we were working in the type section of the Hell Creek. And I've been talking to Bob Sullivan a bit about this. And they get a lot bigger the closer you are to the sea.
Interesting.
Like, not so much because they're marine influence, but the channels are much larger and there's just like bigger fish, bigger pond, right?
And we're pretty close there with the work that we were doing in Wyoming. Pretty close to the seaway, we think, so that makes a lot of sense.
It makes sense with the North Dakota stuff, because all the ones I've seen in most of the Hell Creek, they've been much smaller, you know, inch or an inch and a half centrum, but the ones in North Dakota are really big.
Huh,
but they would have been a lot closer to the seaway and probably much bigger channels and more space for them.
Right, yeah. While we're talking about freshwater fishes, we've got our Lepisosteid right here, our gar. Can you tell us about the Captain Denver gar specimen?
When was that, like 15 years ago?
I just remember that name. It always makes me chuckle.
We were in the Hell Creek. It was near Jordan. And there were these reddish organic rich layers you get there, and you hardly ever get anything in them. So I was saying to people, oh, and here's one of these layers. You don't have to look very hard here because you never find anything. And there's all these vertebrae sticking out. I'm like, and they were a gar. Yeah. And so Liz dug that out. And it was very, very organic rich, and so on top of a hill as well. So every day the crew would come back looking like they'd been working down a coal mine with like black soot all over their face. Well, not soot, but coal dust all over their faces. But it turned out pretty good. There was it was disarticulated, but basically a complete skull, and there's some fins. It wasn't completely disarticulated. It was like the skull roof and the jaws. And pretty reasonable. I guess the head would have been about that long, as I recall.
Yeah, that's like a big alligator gar today.
Oh yeah, it's a big fish. Lots and lots and lots of scales. I think MOR cleaned up most of it.
Nice.
No one's ever described it to my knowledge, but it's
interesting.
It's a cool specimen. And you know, seeing an articulated fish is really nice to see, but getting a disarticulated skull gives you a lot easier to compare with the skull bones you might find isolated ones. So we've got an associated but mostly disarticulated skull.
Nice. Yeah. It's a good thing to have. Cool. Thanks, Denver.
Cool.
Yeah. Awesome. Let's see here. And if we see power law expressed in the lineage's evolution, do we see a slowing of evolutionary processes as a lineage gets older? No, not necessarily. I mean, rates of evolution, like studying that can get really interesting because I think there's still a lot that we don't understand about that. Smaller populations can evolve more quickly just because you can have like a new mutation spread throughout a population more quickly when there's not as many individuals. And you get evolution in isolation that happens very quickly. Yeah. Part of the reason why gar and paddlefish, bowfin, and critters like that evolved so slowly is probably partly due to just there's some kind of mechanism in the animals themselves where they don't mutate as fast. But part of it also is probably that these are critters that live in river systems, and so they're all kind of interconnected. It's hard to isolate them, maybe. Yeah, that might be a big part of it. That said, I don't really understand these things all that well. I'm not sure. I'm sure some people do understand this a lot better than I do. But yeah, I don't know. Like evolutionary senescence. You know, there's this old idea. I've talked about this before. People like Henry Fairfield Osborn used to talk. They're like, oh, well, you know, the reason why you get weird heterotroph ammonites, all these crazy shapes to ammonites in the late Cretaceous, and why you get ceratopsid dinosaurs with their crazy horns and frills. You know, it's just like, it's an old lineage, and they're just kind of, they sort of lost it, you know? They're going senile. And that's a ridiculous idea in a lot of ways, I think. Yeah. We just talked to Denver, so I don't know if I want to bug him about this, but I'm sure he'd have some insight about that. Yeah. But another thing with the gar and the paddlefish and bowfin is that their environment doesn't really change that much. Like, they're living in a freshwater environment in river systems, and those the conditions aren't really changing that much. The climate might change a little bit, but like same with crocs for the most part. Like, if you're in a freshwater environment, you can move up and down a river system as you can go higher or lower latitude or whatever, but like, you're still basically doing the same thing. You're and stuff. There's not a lot of specialization. Yeah, does that make sense? Yeah. Anywho. Yeah, maybe we'll bug Denver about that too. We had a question in the chat about, it was kind of recalling that old idea of like evolutionary senescence, that like when a lineage continues, they start to just do weird, crazy things, like heterotroph ammonites or ceratopsids with like all these weird display structures. Was that Osborne who came up with that idea, or you know what I'm talking about?
I do know, but I don't remember.
Yeah.
Who it was.
Yeah.
I mean,
what's a better explanation for like why those weird features evolve over time?
I think that it's really a case-by-case basis.
Fair. Yeah.
I mean, senescence can mean a lot of things, like the idea that the longer a lineage has been around, it might become narrowed in its morphology is another way. Like, particularly, we call them living fossils. You look at something like inarticulate brachiopods; they actually have a limited amount of variation in them because they become hyper-specialized for their narrow niches.
Why do you think they become hyper-specialized? Is it like they just lose diversity over time? And
lots of what we have left of these fossil living fossils. I like the term living fossils, by the way. I think it's very useful.
A lot of people hate that, so that's an interesting take.
Yeah. Think of coelacanths as living fossils as well. Coelacanths used to have a global distribution, more or less global. They used to live in lots of different environments, and now they're basically very limited to the abyssal plain or whatever. And that's probably reflective of not like they specialized to that area, but they used to have a broad distribution. They went extinct everywhere else.
So they're relics, essentially.
Yeah, they're relics.
Yeah.
And I don't know, they have the morphology suits that relatively unchanging environment. That's not really the senescence you were talking about. I mean, I suppose I don't see the ceratopsians or anything as being senescent at all. Right.
They're evolving really quickly. They're really vibrant, dynamic animals. Like,
but I see that the increase in the elaborate nature of the display organs.
Yeah.
This is part of what I cover in the last chapter of my dissertation, the one that needs to be published. But it's basically related to speciation and related to sexual selection, and the two are not different things. I think they're opposite sides of the same coin to some extent. And one kind of drives the other.
Yeah.
So, but I don't think that it's anything to do with the lineage just been around a long time.
Yeah.
I think that largely these things are reflective of. Sorry, it's very dusty, windy. Yeah, really, just like the environment and how it's affecting these animals.
Sure.
I don't think it's anything about senescence.
Yeah, like longevity of the lineage doesn't really have a whole lot to do with that, except I guess eventually things happen if you're around for a long time, but it's...
But isn't everything that's around today, hasn't that been around a long time?
It has been. Everything goes back to Luca, you know? Yeah. Who lives on the second floor.
I mean, well, no, but like mammals, I mean, you think, mammals are quite new. Well, not really. I mean, my lineage goes all the way back to the Precambrian and beyond. Yeah. Like the idea that ceratopsians were senescent because they'd been around a long time is like, well, they've been around the same amount of time as every other lineage.
Right. That's a good point.
That was up to that point. I mean, you can say that they might specialize into a particular niche and then persist in that niche for a certain amount of time. But
Right, yeah.
they're not just genetically sort of running out of ideas.
Well said, yeah. Thanks, Denver. I really put you on the spot there.
I'm not sure I really answered any question.
No, that was good. Yeah. Yeah, let me go walk around, and we got a raid, so let me greet everybody. And hopefully we don't have some weather coming in.
I'll look on the radar.
Okay, nice. I've got the Wi-Fi if you need it too, but I'm sure you got a signal here.
Yeah, I got that.
Yeah. Who did we get a raid from? Let's take a look. 63 raiders from Mr. Lewis King. Well. How are all those mischievous little beady-eyed mammals doing? And how are the rats, for that matter? Chatters, raiders, how you doing? Welcome to beautiful northern Montana, where it's kind of cold and windy today. And very quiet, of course. We've got a great big excavator on site helping us out, removing overburdens so we can get down to where the bones are. But I'm working with the Badlands Dinosaur Museum out here in northern Montana. And we're digging up dinosaurs and lots of other critters from the late Cretaceous period, about 76 million years old. This is what I do during the summers when I'm out in the field, trying to show you firsthand what paleontology is really like. How do we excavate these fossils? How do we gather data? How do we do all that cool stuff? This is it's my way of trying to show you rather than just tell you. So welcome to Paleontologizing. Yeah. But yeah, good stuff. Good stuff. Surely we have some raiders still left over from the raid. Not everybody fled, right? If you're here from the Mr. Lewis King's raid, let me know. We had Ms. Drop Bear and Megbop and Benchy. Hello to you. They're went into their rat holes. I guess so, Claire. Yeah. Thank you, Ms. Drop Bear. It's good to see you. And how was the stream? I hope it was really good. Did the rats get up to anything particularly funny? Was it a rat stream today? Any rat crimes to report? And thank you. Oh, it's windy. Thank you, Chewknackers, for chiming in. Welcome to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here with a crew of fellow paleontologists and students and volunteers digging up dinosaurs and other critters. And hopefully, we're not going to get rained on by that rain cloud right there. Although it does seem like it's headed straight for us. So, we'll see. We'll see. And what's on their bucket to find any dinosaur, fish, plants, or other specimens? I know one thing that we'd love to be able to find here is more of this pterosaur, this flying reptile. That would be really, really cool. We've got a bunch of elements from it so far, and hopefully there will be more. Yeah, what else would we really like to find here? Taya, anything in particular that you're really hoping to find?
Tyrannosaur, but I'm a little biased.
Tyrannosaur? Yeah, nice. Yeah. Would you prefer to find a big or a small Tyrannosaur tooth in here? What would be more scientifically informative?
They both would be in their sort of own way, but
Yeah.
I think smaller one just because everybody gets hyped up by the
Nice, okay.
tooths.
Cool.
I'm not working on that right now. I've got probably a bit of a hadrosaur.
Yeah.
Found some more of this guy from earlier.
Oh, that's continuing?
Well, I think this is two separate things.
Oh, nice, okay.
And then there's this guy, of course, but
Yeah. It is looking more and more like a phalanx, I guess.
yeah,
Nice.
yeah. I did find a hadrosaur tooth.
Oh, nice.
Yeah. Little guy right there.
Oh, there we go, yeah.
And you
Here,
can-
let me get the magnifying glass again
Yeah.
for chat. A tooth from a duck-billed dinosaur.
Yeah.
There we go, check that out.
And that's actually the grinding surface too,
Nice.
which you see actually change through growth.
Uh-huh.
So in the little tiny baby hatchlings, you get these cup-shaped.
Oh, weird, really?
Yeah, wear surfaces. So
Huh.
probably eating like squishy things.
Yeah.
Think of like fruit, but fruit weren't really a big thing back
Sure.
then.
Would it be like horsetails or something?
Maybe,
or?
I don't know. Maybe the adults were chewing things up and spitting it out again. I don't know.
Okay, yeah.
But it was very, very like sort of soft, pulpy type things. And then as they grow up, not only do they gain more teeth, so hadrosaurs are really weird in that they start off with one tooth in each tooth family, so that's what we call each tooth position in the jaw of a hadrosaur. And so just like us, they would start off life with a single tooth in that position, and then go and be super weird and develop a second tooth in each tooth family, and then a third, and then a fourth even.
So you've got like a row of teeth.
Yeah.
It's hard to describe, but like if you're looking at it from the front view, it's what we call a tooth battery. So like you've got a bunch of teeth that are all working at the same time, kind of stacked up. Yeah. And then this extends all the way up and down the jaw like that. Yeah.
Exactly.
Really weird and cool.
My dad describes the lingual, so the tongueward side, kind of like a gun magazine almost.
It kind of is, isn't it? Yeah.
So they're already ready to go. But the wear surfaces actually change with the number of teeth as well. So when you have that singular tooth in each tooth position, they're the cup shaped, so that's the little embryo guys.
Yeah.
And then when they grow up a little bit more, they get 2 or 3 teeth, and they become these like shearing surfaces, so for cutting things. And then when they become the really big adults, you get this really weird combination. So at the front, there'll be these like shearing type surfaces, and then they'll come back into sort of more this like cup or scoop shape. So that they can grind stuff. So the adults were probably eating a bunch of all kinds of different things.
Like maybe potentially really tough plant material.
Yeah.
I know that some hadrosaurs have been found with like pine needles and stuff in their gut cavity. Whether or not that's their typical diet or whether they ate right before they happen to die, because I don't know. Anytime you find like gut contents, it's like, is that really what these animals were eating on the regular, or is that what killed them? But,
exactly.
Yeah.
Like that juvenile tyrannosaur with the cagnated bits in its
stomach. The 2 different like leg bones from 2 individuals. It's the same element.
That one's wild.
That is really cool. Yeah, from up in Canada, right?
Yeah. Darren Tanky, I believe, worked on that one.
Nice. Okay. Cool. Yeah. If you have any questions about Canadian dinosaur paleontology, Taya's your gal, so don't be shy. But yeah, cool.
Yeah.
Thanks, Taya.
Yeah.
Nice.
But it might be an interesting lump.
Fossil lungfish? Lump. Oh, okay. Oh, yeah.
Now, that's the sort of thing that it might be boring. Or if we're lucky, it might be something interesting. It looks like it's got solid shape all the way around. What is it? Well, it could end up being a weird piece of limb bone, but at the moment I'm thinking, what am I thinking now? Because the challenge.
Looking at that.
It's one of my favorite things to find if it is what I think it is.
Is it a coprolite? Is that what you're thinking?
No, but that is one of my favorite things to find. But
remember how excited you get about the croc coprolites with the spiral shape?
Only when they have the pinchy bit in it.
Yeah.
Oh my god.
But when you find these sort of lumps that are made of bone, but they're all kind of amorphous, like sometimes they can be little ankylous or dermal ossicles. We get quite a lot of those in this coulee. This one could be that, or it could be something like a wrist bone.
Okay, yeah.
It's
carpal, yeah.
When you find a lump of bone it looks like it's intact, it looks like it hasn't got any broken edges.
Yeah.
But you can't tell quite what it is because it's a weird shape. Sometimes you've got one of them interesting weird bones.
Right, yeah.
So,
neat.
It'd be about the right size for like an ankle bone or a wrist bone from one of the little theropods that we got in this. I don't know if it is or not. I mean, it could just. But it doesn't look like a weathered lump.
Nice. Well, I hope it turns into something cool. A carpal would be really neat, or an osteoderm.
Yeah, I'm gonna give it some glue. I thought you could see it before it was a bit shiny.
There we go. Yeah. Well, and I think we do have some Plockman's mustard emotes in the chat. That way, they're not mine, but one of my moderators, Lenina, made some. People love the idea of the mustard bottles in the field. It's
they're really practical. They don't last. You get a couple of seasons out of one before they get grotesque. But
I have like 4 or 5 of them that I can donate to the group. Mini ones that I brought with me. So
that'd be cool.
If you want more, yeah.
There always an excuse to try different sandwich sauces.
Yeah.
Like, oh, that one's in one of them twisty top ones. We'll have that. Like that curry one I got the other day is in one, so that's my excuse.
Yeah, yeah.
I need the bottle.
You've got to have something like this at a restaurant supply store where you could just buy a bunch of it.
They do, but you'll pay $1 a piece. You can just buy it with mustard in it for that price.
Yeah.
So it's cheaper and easier just to buy them.
Do you get
off
those
the
in the
shelf.
store in North Dakota? Like,
Very few, only this particular brand.
Just Blockmans?
I think.
Yeah.
But like, you do get that twist cap on more other sandwich ones. Like
sriracha sauce and stuff. You can
yeah,
get that.
sriracha again. The curry one that I just got last night. Get it in that. Very
Nice.
tasty.
Yeah, yeah. Cool. I had to buy those special off Amazon. They weren't cheap, but it was after the bottle, and I got to use the mustard, so
The standard glue bottles, the Elmer's glue bottles.
Yeah.
The white glue. Those are really good too.
Okay.
They're a little bit smaller, so we tend to use them for delicate stuff. But,
Have you encountered any plastic bottles like that the glue just dissolves? Like the chemistry just isn't right? It just eats right through?
No, just because we've always bought the same ones that we know basically work.
Nice, yeah. Cool. Yeah. Anyway, one of these days, get a Plockman's mustard sponsorship. And,
Exactly. It's great stuff, but I can't eat 5 bottles in a year.
I told you about that time back when I was in Montana where, my girlfriend at the time were like, well, let's come up with some mustard recipes. So we had mustard tofu bake thing. It's not great.
We tried the same like mustard-based barbecue.
Uh-huh.
We're the only ones.
Uh-huh.
When I was with Bob Sullivan, like he really likes hot mustard, so I used to bring him a big catering bottle of Ullman's yellow mustard every year.
Uh-huh.
I don't know how he got through it because I have a little pot like that. It's like a lifetime supply for me. He'd get through like a big 1.5 liters of it in 12 months.
Speaking of that colleague and glue, do you want to tell that story, or should we not do that on camera?
Well, now it sounds really bad. It's not really.
It's not really bad. No, it's funny. I know I've told the story before on stream, but I don't know.
Told it before.
Yeah, I have. Yeah.
Okay. Well, I was halfway up a mesa. I'd found a nice ankylosaur scoop.
This is out in New Mexico.
Yeah.
Yeah.
In New Mexico. This would have been about 2002, maybe 2003. And Bob's waving his arms at me, and I think, oh my god, he's found something really good. So I go running down to where he is, and I see him standing there surrounded by this sort of arc of glue. He says, I just drank some glue. And his glue bottle and his water bottle look the same.
Yeah, he put them both into an Nalgene.
Yeah. That was before I'd worked with Museum of the Rockies and who used these mustard bottles.
Yeah.
So I said, well, how do you feel? He's like, I feel okay. I'm like, well, you're bigger than me. Like, there's only us. Like, I can carry you back to the truck of it. Anyway, he didn't drink much. I think he spat it out. And it's not good for you by any means.
Definitely
but,
not, no.
It's probably not terminal.
Yeah.
Not yet so far, anyway. It's good reason not to have your glue bottle and your drinking water in the same kind of bottle.
Don't get these mixed up right here.
Yeah.
Is this the same one from this used to be bright orange, right?
That one actually is a New Mexico one. The top, this bit is about, the main bottle, and this is 24 years old.
Wow.
And this one is a little bit younger, that's about 20 years old. When I used to buy these, you can't get them very easily anymore, but they're really good because you can click them open and drink them straight away.
Yeah, yeah.
And the little handle.
Yep. Nice. Nice, Denver.
This rain should blow through.
Okay, it might get a little heavier because I see kind of a rain curtain there. I'm gonna reposition a little bit and put my stream encoder under the coat. But all the rest of the gear should be okay, I think. Maybe I'll stick something over the solar battery. But hang on just a minute, chat. Bear with me here. Come on now. Ugh. Like that. What am I doing here? Yeah. Well, I'm just gonna stand like this to keep everything out of the rain. But Yeah. It's just a really small cloud there. It's dumping some rain on us, but that's not the worst. Hopefully it'll be over in a minute. Yeah. How'd the bank robbery go, John?
Oh, it was helping out with the dust and
Yeah.
not much use for it now. But.
That's typical, yeah. We have a lot of bandanas over the face in the quarry oftentimes, but yeah.
No, and it's actually really useful to have it on the back of the neck as well, because if you're actually midday, if you have that exposed, you can get really bad sunburn.
For sure.
But sometimes I just flip it on the other side, and it gets often really dusty out here. So.
Oh yeah. No, it's a useful implement to have. Like, I don't know, use bandanas for all kinds of things. Sorry, chat. I'm wiping your face right now. There's drops on the lens. But yeah. And Andrew says, bummer. I mean, at least it's not too hot, right? Yeah.
Really cold, actually.
Yeah, I know. Yeah, Gabriel, you're not used to cold rain, right?
No,
it rains
I'm
in
not.
Puerto Rico, and it's
Yeah.
it's always warm.
It's always warm.
Yeah. Yeah. What do you think of Montana so far?
It's great, yeah.
Yeah. Maybe not as pretty as Arecibo, but few places are. Yeah.
Yeah, but I like the field work that
Yeah.
we've been doing here.
A lot more
It's great,
outcrop
yeah.
here than on the islands.
Yeah.
Yeah.
Definitely.
For sure, yeah. Yeah. And Charlie's not giving up. Working through the rain.
Yeah, I gotta turn.
What are you doing over there?
No, I don't know on that.
Actually staying somewhat dry.
There you go. Nice.
This isn't too bad.
Yeah.
Far worse.
I might change my background to a new photo here.
Nice. Well, Charlie's maybe a couple years younger than me. Do you have any favorite Twitch streamers? Anybody you want to shout out?
I actually don't watch Twitch.
You don't watch Twitch?
Yeah, I'm like chronically online in a very different way.
Very different way.
Yeah.
So just
Like Twitter,
GeoCities or you even know what that is?
Yeah.
Netscape browser. IRC chat rooms. No. Nope. Yeah. I like your sweatshirt.
Oh, thank you.
California, yeah.
I
me
mean,
homesick.
my sister was touring universities there like a few months ago.
Oh, nice, cool.
And it says really comfy. I wasn't there.
Yeah. That's nice. I like to see people repping my home state.
Where are you from again?
LimeWire says Lilith Hobo. Yeah, I don't know if anybody, under the age of 30 knows what LimeWire was. Maybe that's for the best. Yeah, I'm trying not to get too much water in the inner workings of the camera. But and this is the thing too, where like you get dust with the rain on top of a surface like this, and it's just everything turns to muck. Anywho, if anyone's just joining us, welcome to Paleontologizing. We're enduring a brief bout of rain here in northern Montana at our dinosaur and other critter dig site in the late Cretaceous Judith River Formation, which might be closer to the Dinosaur Park Formation in terms of fauna, actually. But I'm glad you're here. Let me know if you've got any questions, and we'll get back to digging in just a little bit, hopefully once this rain passes. Yeah. Anywho, take a look at that lovely landscape right now. So much greener than Wyoming, probably because they get these periodic rains like this. And also, just there's higher humidity here too. It's not quite as dry as the part of Wyoming that I was working in last week. Yeah. Glad I brought this coat today. Alexander says, did I miss any croc talk? Yeah, you missed a croc tooth. Sorry, man. Yeah. It was cool. Here, let me back up over here. Anywho, I can mostly protect all my gear from the rain if I stand like this. Yeah. We need more tarps out there, says Claire. I mean, yeah, and what I should do is stick something over my solar battery so it doesn't get too wet. Usually the jackeries are pretty solid, but I don't want to risk it. I'm good for now, I think. Thank you, though.
I mean, it should flow through.
I'm just going to stick this over the jackery battery so it's not getting raindrops directly on it, but I think it should be fine. No, it's fine. Feels like it's dying down anyway.
Some sunshine?
There we go. Anywho, yeah. And Black Ice Lichen says, is that a phone on your wrist? It is, yeah. This is how I'm reading your chats. I think that's pretty standard for IRL streams. That's not too unusual. But I've been streaming like this from the field IRL since what, 2021? Something like that? 2022? 2021, I think, yeah. All our IRL streams from various museums and field sites. So, over the years I've managed to, glom together different pieces of equipment and find out what works and what doesn't, and really kind of, develop a system that just functions pretty well with minimal effort. Oh, yeah. And I'll see you next time, Alexander. Thanks for being here. Enjoy your dinner. Yeah. In 2023, you got another quarry. That's true, isn't it, Claire? Yeah. Yeah. And Akira Eclipse has got a question about sexual dimorphism in dinosaurs. That's a tricky subject. Let me explain to the chat what that means. Sexual dimorphism is when you get differences between the different sexes, usually male and female, in different organisms. And we don't have strong evidence of that for dinosaurs. Not morphological, osteological sexual dimorphism. People have been looking for differences in the skeletons of male and female dinosaurs basically forever, since we've known about dinosaurs. And we don't have really many good examples. We don't really have any good examples at all. It's been suggested that, maybe different crest shapes and sizes and lengths and stuff of hadrosaurs has to do with, differences between the sexes, but it turns out it's probably mostly differences between different growth stages, young and old, what we call ontogenetic variation. Yeah. Recently there was a paper, I think they were looking at ornithomimids, is that right? From Europe. And they claimed that there were different leg bone proportions in males and females, but I kind of have my doubts about that. It would not be shocking to me if you just don't have osteological sexual dimorphism in dinosaurs. We certainly don't seem to have that in birds much at all. Nor do we have it in crocs, really. So, yeah, there could be differences in the soft tissue, coloration, plumage, things like that. Nice.
Yeah, that was great. Yeah. You get that on film?
A little bit, yeah. Incontrovertible evidence that any dinosaurs were male. They probably were, but We can't prove it yet, beyond the shadow of a doubt. So, I don't know. It'd be pretty unusual. But yeah, maybe you just didn't have male dinosaurs. Yeah. Oh, did the stream cut out? I'm sorry, chat. Yeah. Anyway, that happens sometimes with the satellite. But yeah, wipe this off the screen. Now, this is the lousy thing about touch screens, is that when they get wet, sometimes they don't respond properly, and this one is not responding. Come on now. There we go. Stupid thing. Oh well. Ignore that chat message. Yeah. Okay, you can see me now? Good. Anywho. Alright, the rain has stopped. Nice. Hopefully things aren't too messed up in the quarry.
It's pretty good.
Yeah, nice.
Right before the rain hit, I found a champsosaur.
Oh, a champsosaur? Vert? Oh, nice.
Yeah, like a
yeah,
nice
that classic
little,
like hourglass shape there.
Yeah.
On the one side. Nice. Very cool.
This is the top view.
Yep.
And you see little processes for the ribs.
Very nice. It's dorsal there. Thanks for showing us. Nice. That's so weird. We don't get any of these in Wyoming.
Really?
Campanian or Maastrichtian.
Canada, they're so freaking common.
Yeah,
like,
it's so bizarre, like working in these age rocks and not finding a single bit of champsosaur. It's
if
bizarre.
I was prospecting and I picked this up and I showed it to Phil, he'd be like, "No, why did you bring this back to me?"
They're just
And
incredibly
it would just
common,
be like,
Yep. Yeah.
but we got this, so.
Nice. Yeah. Excellent. Yeah, champsosaurs are cool. They're these weird, almost lizardy kind of reptiles. We're not totally sure where they belong phylogenetically. Excuse me. But yeah, we know they're not crocs, but they're part of a group called the Choristidaira. But where does the Choristidaira belong? I don't know. Champsosaurs, they're like lizardy guys who really want to be crocs. They probably mostly ate fishes. Got these long, gharial-like snouts with these needle-like teeth, and didn't have scutes like crocs. And it might be that they're better adapted for colder environments than crocs are, although we also get crocs up here. I don't know why we don't get champsosaurs further south. Yeah, it's bizarre. Maybe there's a particular kind of fish that they're eating or something. I'm wildly speculating now. We don't really know. But, and thank you for the blessings, chat. Yeah. Yeah. Anywho. And does the environment on screen count as green to you? Yeah, it is. It is pretty green out here, Charlie's Dragon and Lady Elaine. Again, coming from Wyoming, where things are very brown. Here there's grass everywhere. Like, that's nuts. It's all sagebrush country down where we were working last week. It feels incredibly lush by comparison. You even get trees, like there's cottonwoods down there. It was almost like there wasn't a tree in the whole county where I was working last week. But, yeah, there we go, cottonwood trees. And again, for those of you who weren't here earlier, you see that little speck out on the horizon? That's a pickup truck out there that I'm pointing to. That belongs to Carrie Woodruff, who is another alumnus of Montana State University. And he has got a crew on the other side of this coulee, digging up dinosaurs. He came all the way from Miami, Florida. He works at the Frost Science Center, Frost Science Museum. And I interviewed him, about 6 months ago? Live on stream. Somebody can post a link to that VOD if they want to. Interview with Dr. Carrie Woodruff. But he's over there. He used to share an office with Denver back in Bozeman, and now he's right over there. Small world. Nice. Run over and tag it, Alex. That's a long way to run. That's at least probably a mile and a half, especially if you count the ups and downs. This is not an easy walk to get over there. A water stream, not like a live stream. Yeah. Anyhow. And abiotic reproduction. You mean asexual reproduction? We don't know that. No. Well, actually, no. I take it back. We do know that. There's at least one species of dinosaur today that can reproduce asexually, and that's the California condor. We call that parthenogenesis, where a female can actually produce offspring without the assistance or input of a male. She basically just clones herself. To my knowledge, the California condor is the only bird that this has been observed in. So maybe it was possible for non-avian dinosaurs to do the same thing. Maybe. I don't know. It does not seem common in birds today, so... But I think crocs have also been known to do that, so... Yeah, I don't know. Yeah, girl power. Hey, Lordy, how are you doing? Welcome, welcome. Yeah. But yeah. And all that overburden being left in mounds makes me sad. It will be returned to the land. Addicted to capping? Absolutely, yeah. So here's the thing. At an area like this... Oh, Denver, we got some visitors. Nice. In an area like this, I don't know, it's hard to make a living as a plant. Maybe not as hard as it is down in Wyoming where I was last week, but, you know, you look at this kind of landscape and there's one of these places, new plant growth, you know, if seeds have a difficult time germinating in a place like this, but where you have a lot of disturbed ground, like at a quarry like this, these big mounds of overburden like that, they're going to be prime habitat for any seeds that happen to drift in. So, you know, give it a season or two and this will all be grassed over. And that's if the Bureau of Land Management doesn't decide to use this material for some other purpose, like dam fill or, you know, buttressing a road or something like that. But yeah, given a little while, little grass all over this. And all kinds of little critters are going to love that loose material too for burrowing into. It's just going to be a boon for the local ecosystem. Yeah. It's fun to think about. Yeah. But anywho. And Lady Elaine says, how often are fossils damaged or destroyed by industrial quarrying? Oh, like every single day, every hour of every day. I don't even want to think about that. There are happy examples of fossils being found in industrial mining operations, like Borealopelta is a good example. That beautiful armored dinosaur, that nodosaur from up in Alberta, from the Suncor mine. There was a heavy equipment operator with a keen eye who realized, oh shoot, that's a weird thing. And he stopped, backed away, and it's like half of a beautifully preserved ankylosaur just right there. I don't know if he dug through the other half or what happened, but like part of it was missing. Yeah, that sort of thing must happen all the time, and nobody realizes it, you know? That's the reason why we're working so slowly and carefully through all of this. We're finding all kinds of beautiful, smallish fossils. there isn't really anything that I know of in the layers above, but down here is the productive stuff. And as Denver was discussing earlier, there's particular layers in here that are yielding really, really good material. And you find different things at different layers. There's a lovely plant layer. We've got this gravelly stuff with all the small vertebrates in it. It's cool how these things kind of work out in patterns like that, where you can start to predict where you'll find different things, and then those predictions come true. You know, look really carefully through this layer. You know, you'll find lots of vertebrates, and then there they are. Yeah, again, it's the kind of thing that you only learn through experience. And Mr. Henry asks the most common question that we get out here. How do you decide where to dig? The answer is we dig where the fossils are. Yeah. That was a notosaurus, Hussey, yeah. Anyway, no, I'll give you a more detailed answer than that. The way that we decide where to dig is we literally just walk around a landscape like this and we look at the ground. So it's not like we just pick a random spot and dig a hole. That's not how this works. We do what we call prospecting. So you walk along some badlands like this, looking down at the rock, and you're picking up little bits and pieces of things. Is this bone? There's some like sandstone concretion-y stuff. That's not bone. What is this right here? This white fleck? Ooh, that is a piece of mollusk shell. Probably a clam or a snail. That's interesting. You just keep doing that until, oh, well, look at this. Bone right there. You see that texture? That is fossil. It's eroded out. Yeah. So basically you walk along, you're hiking around, you've got your eyes glued to the ground. And then you find little bits of stuff like this. And you find more and more bits. You follow them up like breadcrumbs. You find the source and you dig in. And that's exactly how this site got discovered back in 2020. Jack Wilson, who's another paleontologist, actually a former roommate of mine from back in Montana, he was working out here with Denver. He found this site because he found some interesting bone fragments, found the source, dug in, and there was a Lambeosaurus skeleton in there. That's now the Liberty Lambeosaurus skeleton. There's a gorgeous skull that's back in the museum. So they were working over there in that quarry, basically right behind the backhoe, right behind that excavator. And they were working there for a number of years. So they were kind of hanging out in this area, and then they started finding more and more bone fragments over here. And then this turned into a really important site with all kinds of cool critters coming in. Kind of a lovely sample platter of different, late Cretaceous organisms. Does that make sense? Yeah. And is that the same piece you found earlier? I think it literally is Charlie's Dragon. Yeah, but there's other bone pieces over here too. They're all over the place. Put this back. That's just the most obvious one, but there's other chunks floating around. Yeah. And let's see. Quixotic Odyssey says, what do you do if you find gold or jewels or oil or artifacts? You go to a different place because that's not where you find fossils. Yeah. You're not going to find oil in an area like this. This is sedimentary rock. This is soft rock geology here. So we've got mudstones and sandstones. This is not the sort of environment that you would find petroleum in. And if you're finding human artifacts, well, then you're usually digging in topsoil, That's not this. This is rock here. And these rock layers have been in place for 70 plus million years. You're not going to find arrowheads or old Coke bottles or anything in these rocks. If you do, you're looking in the wrong spot. You're looking in loose soil, It's like I often say, paleontologists dig in rock, archaeologists dig in soil. Does that make sense? Yeah. Likewise, you're not going to find gold in an area like this either. You don't have the right kind of orogeny. gold is often found in like where mountains are coming up, and you have magma that's pushing things around and metamorphosing stuff and kind of leaching that element gold out of the surrounding rock and concentrating it. You're not going to have that in a place like this, if that makes sense. Yeah. And Vitani Lunatica says, who decides when to start prospecting for new sites? The crew chief does. So this is Denver Fowler's field program out here, and he sends people out to go looking for fossils. And Jack Wilson has got a long history of finding good fossils. So Denver had him do some prospecting in this area. They're hoping to find some new sites, and they did. So, yeah. I may or may not do some prospecting while I'm out here. Probably not, actually. I'm out here for about another week. And, yeah, frankly, I'm not going to do that much digging because so much of my day is spent yapping to all of you on camera. So, yeah. Yeah. And Crimson says, even if you were to find such treasure while digging for fossils, would you even be allowed to claim it? I don't know about that. I've never really thought about it because it's just not something that crosses our mind. We're not after that kind of thing. But it would depend on the land ownership. So we're digging here on Bureau of Land Management land, BLM land. So this land is administered by the federal government, by the Bureau of Land Management, and we have special permits to be able to prospect here and to be able to excavate here. So Denver and Co. applied for a big excavation permit, which meant that we could move a lot of rock in order to be able to find these important fossils. And then, as a result of them being found on public land, that means these fossils belong to we, the people of the United States. These cannot be sold off to a private buyer. They can't be in a private collection. They have to be in a proper museum, what we call a repository. So a repository is a special institution where fossils or other specimens can be held in the public trust. And that means in order to become a repository, you have to demonstrate that you're not selling things. Everything will be there for years and years and years in a safe, secure location. And there have to be plans in place so that if for whatever reason something terrible happens and that museum has to close because of budget shortfall or whatever, there have to be plans in place to transfer all of those specimens to a different public institution. The point is, we're keeping these fossils in the public trust. So they don't belong to any one person, they belong to the people of the United States. They need to be available for scientific study, and in a lot of cases for public display. You know, what we're doing out here is a public good. We're not out here digging for fortune and glory. That's not what we're about. We're scientists. We're doing science, collecting scientific specimens. And the cool thing is, the fossils that we're excavating right here are 70 plus million years old. So there's that kind of beautiful timeless quality to them. I say timeless in a metaphorical way, not literally timeless. We know how old they are. Anyway, but also, long after all of us are dead, these fossils will still be in a museum for future generations of paleontologists to study and for future generations of the public to enjoy. So when we're working here, we're not getting paid. We're all volunteers on this site. But we know that the work that we're doing here is going to last for generations, These fossils will be there in a museum for as long as the concept of a museum exists. You know what I mean? And it's cool to be part of a larger project like that, There's a certain kind of fulfillment that I think we all get from that, where it's one of the special parts of being out in the field. We're not doing this for personal gain. We're doing this because it's part of a larger project that we all believe in and want to contribute to. And not to get too philosophical about it, but I think it's a really important part about, having something to live for. When you can be part of a larger project like that, it's fulfilling. It's something special about that. From this that few other things can provide. And I wish more things like that, you know? It's really nice not to have to worry about the bottom line, about profit, about personal enrichment or whatever. All that stuff I feel can, at a certain point, it can kind of corrode people's humanity. When you're doing something for the greater good, that's one of the things that can bring true happiness, in my opinion. Anyway. Yeah. So cool. We've got some folks from the local area that Denver's touring around the site right now. So showing them all of this. I think they might be relatives of our heavy equipment operator here. So good folks. We're grateful for them. Grateful to them for the help. And this is where they live, you know? It's cool for them to be able to see something right in their own backyard. I don't know, I lived in Montana for the better part of a decade, and there's a certain kind of pride that comes with the knowledge that you live in a place that is one of the best in the world for dinosaur fossils. It's something to be proud of, you know? It's something that I don't really have back home in California. California is not known for its dinosaur fossils, and rightfully so. We only have a handful of rare dinosaur specimens, literally just like 4 or 5, to my knowledge. California's got a million wonderful things going for it. Dinosaurs aren't really one of them. Montana has dinosaurs in spades, and so do other Rocky Mountain states like Wyoming, Colorado, Utah. It's something to be proud of. So it's always cool when we get to share that with the people who live here. It's like, hey, you know? And so one of the things that Denver's actually done is the skull Lambeosaurus. He's made multiple copies of that, what we call casts, some molded and cast replicas. And he donated one of those to the local library over in Havre, which is one of the nearest towns to here. So, and I think it was just like a couple weeks ago that he donated that. So that'll be up on display, and everybody who goes into the library will be able to see that and know that that dinosaur came from right here. And are those pieces of bone on the surface not collected? Yeah, Gentle Freak, those ones are... They're not diagnostic, they're just fragments, what we call float. So float is our colloquial term, our slang phrase, for the bones that are on the surface that are just kind of blown apart. They're floating there on the surface, essentially. They're a good indicator that there is bone underneath, but they themselves are just fragments, and they're not going to be scientifically valuable. You can't even use them for stuff like isotopic analysis, because they've been eroding on the surface, and they've been chemically altered through erosion. So yeah. The dino slag. There you go, C-152 flare. Basically, yeah. Yeah. Anywho. Yeah. Anyway, good question. If anybody else has got any questions, don't hesitate to ask. But yeah. If anyone's just tuning in, welcome to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. And I'm giving some folks in the quarry some space right now as Denver around. But let me know if you've got any questions, huh? Yeah. And Steve says, the float is good for stirring Spam into mayonnaise? Is that right? I'm not particularly fond of either of those ingredients, fossil preparator. Especially not the Spam. But yeah. And Mr. Henry, yeah, you live in Glendive. Very cool. I've been to Glendive many times. Yeah. Makoshika State Park is there, which you mentioned. There's a lot of Hell Creek strata there, so a lot of the last of the non-bird dinosaurs, Triceratops, Tyrannosaurus, and Montosaurus, and their friends. Yeah. Makoshika it's a cool place. It's a cool place. Yeah, the rocks that we're digging in here are about 10 million years older than the rocks at Makoshika. So they're from an earlier time in the history of dinosaurs. Although in the grand scheme of things, they're still very late. Dinosaurs first evolved about 240 million years ago, and then the asteroid hits 66 million years ago and wipes out all the dinosaurs except for a handful of bird species. These rocks are about 76 million years old, so they're near the end of the age of dinosaurs. Yeah. Anywho. 10 million years exactly, Pate B, yeah. Yeah. Huh. Yeah, let me know if you've got any other questions. And we're getting some sun and everything. It might be about time to take off the jacket. We'll see. We'll get out of the way so John can dump some some matrix over here.
Oh wait, hold on, I'll do it.
Yeah? Nice. Like we always say, a clean quarry is a happy quarry. So when we have, detritus to throw away, we tend to do that down the hill here. Yeah. So what's cool is that, like, if we were to stop working here at this quarry and let it just kind of sit for a couple years, you would have grass growing all over all of this. Lots of critters digging burrows into it. All of that. This is great for plant growth and for burrowing, and we expect that to happen with those piles of matrix that are behind the quarry if they don't get moved by the BLM. Yeah. And no, I've never heard of anybody using a zip line, Timber Squanch. That's an interesting idea. At one point, Denver had an idea to use helium balloons to move fossil jackets. I thought that was an intriguing notion. But, yeah, most of the time when we have to move those fossil jackets, we do it by hand. So you just get a big group of people, and they all lift it up. But I've also used car winches for that kind of thing. So I used to have a 2007 Toyota FJ Cruiser, and that had a big old winch on the front. And we've used that a couple of times to move some big jackets in the Hell Creek. I've also been on crews where they've had a helicopter come in to lift up a big fossil jacket and move it onto a flatbed trailer. That was really nice. But then we had one jacket that was too heavy for the helicopter. So we had to wait a month or two and then call in a bigger helicopter, a Huey. That was something. Yeah, but for the most part, we move jackets by hand because we often don't have the budget or the equipment or the wherewithal to, to do anything else. But here we might be very lucky that we've got an excavator here helping us move overburden with a very skilled operator. And we might ask him to help lift up the Lambeosaurus jacket that I showed you earlier, if that's ready to go later on in the season. That'll probably happen after I've already left and gone back home to California. But, yeah, I don't know. We'll see. And Pumpkin the Cat says... Oh, Pugga Wugga says too big for a helicopter? Oh, yeah. It was a small helicopter. It was like a... What is it? Like an H500 or something? I always forget the actual designation. In the military, they call it a Is it OH500? Is that kind of helicopter? Anyway, it was too small. Like, the helicopter didn't have enough power to lift one of the jackets, which weighed about 2,000 pounds. And how much would it cost to hire some Olympic weightlifters? I don't know, Pumpkin the Cat. Denver talked about that at one point as a joke. Yeah, we'll get some muscle men in here to lift these jackets. Good workout. They'd pay us to do it. But yeah. I think it is an MD500. Yeah, thank you, Claire. OH6 Cayuse. There you go, Crimson. Yeah. Yeah. Anywho. Yeah. We will be wrapping things up relatively soon. I'm glad the sun is out, so at least it's charging that battery. but yeah. Yeah, let's go check in with Gabriel over there maybe and see if he's got anything new. You know, he's working down from the top, so might not have anything super exciting yet. It's nice to check. Anything new and exciting over here? Still working down those layers?
Yeah. Just like I started to run like right at the top.
You made a lot of progress. Wow.
Yeah, and like I've just been digging down to reach the bone layer that's over
nice.
Here.
Yeah. Cool. Made a lot more progress than I did today. Shoot. Anything good over here, Ed?
No, just little scraps of bone that have been, rolled in the river.
There we go. Yeah. See, at least you're finding these, though. If you, I don't know. Sometimes when somebody's just digging, they don't find anything. It's like,
Right. Yeah. Yep.
But yeah. Nice. Little bone beans there.
Yep.
Lovely.
Yeah.
Thanks, Ed.
Yeah, they're little, just real thin bone.
Oh yeah. What could that be? That's interesting. It could almost be like. It doesn't quite have the right texture for like fish skull plate, but could be. I don't know. Interesting.
Yep.
Yeah. Cool.
That's
Thanks,
what
Ed.
I got.
Yeah. Nice. Yeah, better than nothing for sure. Has this turned into anything cool over here?
No. All we had was the carapace earlier.
Gotcha. Yeah.
Yeah, and it's part of a it's like hypotheses, but he was like, it wasn't much. It didn't amount to much. That's about it.
Fair.
And then like a small little bean thing, but it was nothing.
So it goes sometimes.
So it goes.
But
we're getting close to the really good stuff. So
nice. Yeah.
We're getting really close.
That'll be fun. Hopefully they're by tomorrow, and then.
I'm gonna even this out. That'll probably take a while, but hopefully at least maybe 3 o'clock tomorrow.
There we go. Get down to the bone zone. Nice. Cool. Yeah. John, anything good?
So, since you started the live stream,
Yeah.
I really did not expose any of this, and so I've done all this since then.
Nice.
And so my goal was to expand the shelf this way. And obviously I started top down, but I was moving top down this way, and I met up with right here.
Nice.
And my goal is to be where Charlie is over there.
Nice.
And that's where we're tending to find the vertebrate fossils. But yeah, I mean, really amazing work, and it's just. But that's essential work, It's not.
You got to dig through by hand because you never know what you'll run into.
Exactly.
Yeah.
So, but yeah, that's it for me.
Awesome. Yeah, well done. Thanks, John. Let's bug Laura for a second. Anything new and exciting over here?
No, not really. I keep finding little bits of bone as I go, and so all these little foil bits, and I'm just trying to expose more to dig them out and around.
Nice. Cool.
And then
see what Taya's up to. Anything new and exciting?
A little tiny vertebra, I think. Assuming
interesting. Okay.
I'm not hallucinating, but
that's
what I think it is. Kind
that
of cracked
would be
open.
Super tiny. Holy cow.
Don't want to expose it.
Yeah.
Make it Deanna's problem later in the lab. But
nice.
It's got to use some glue right now because it cracked a little bit.
Gotcha. Yeah.
Fortunately, some of the rock breaks so unevenly. It's hard to get it out in one piece.
So unpredictable. What's it gonna do?
Yeah.
Nice. Cool. All right. Nice. Yeah. So meticulous work, as you can see at home, but that's how it goes, See if we got any other questions. I doubt we'll find your car keys. Sorry, Zico. Yeah. We did find some car keys earlier. It said something like Lamborghini or something like that. Does that sound right? But we're keeping those. Sorry. Anyhow. Find me a full dinosaur skull, says Dan the BC man. We're hoping to, There was one from over there. I would show you, but the excavator is in that spot currently. But there's a beautiful Lambeosaurus skull from right over there, and the rest of the skeleton is over there currently that we're hoping to get out this summer. But that skull you can actually buy a 3D print of as a little magnet. I have one at home. The Badlands Dinosaur Museum has that in their online gift shop, so you can pick one up yourself. Liberty the Lambeosaurus. There's also a Daspletosaurus head and a number of other cool things that they've got up there. I need to get the Lambeosaurus t-shirt, which Steve was wearing the day before yesterday on stream. I gotta get me one of those. That's really nice. So maybe I'll even ask Liz to pick it up for me if I buy it online tonight. Although she's probably got enough on her plate. I don't know. But yeah. And how'd they get a Lambo out there? We dug it out of the ground, Neverwinter. You're talking about Lambeosaurus, right? Yeah. What's funny is Lambeosaurus is only known from Canada thus far. There's several specimens from up there. Lambeosaurus lambii, at least, is only from Canada. We've got one from here, just south of the border in Montana. And that's part of a common theme here, as we're seeing some other critters that are not supposed to be here in the US. They've only been found in Canada so far, in the Dinosaur Park Formation. This is called the Judith River Formation out here, but Denver and some other folks suspect they should really be calling it the Dinosaur Park Formation, because it's much more similar to the stuff they get up there in Canada, just a few miles that way. Which makes sense, because the rocks and the animals, you know, they don't care about national boundaries. They don't care about borders. These animals lived 76 million years ago, long before surveyors drew this boundary between the US and Canada. So, yeah. Sometimes the geology, like the names for the rocks, the different formations can be a little arbitrary. It's important to remember how arbitrary they are, because this probably shouldn't be the Judith, it should probably be the Dinosaur Park Formation. I'll let Denver talk about that later, because he's got a whole thing about that. We'll hopefully be publishing a paper on that relatively soon. Dew Feathers, hey, welcome to Paleontologizing. Thank you for the raid. How was your stream? I hope it was really good. Were you doing some zoology? Very cool. We're doing some paleontology here, digging up dinosaurs and other critters, and the late Cretaceous Judith River Formation. Although maybe we should call it the Dinosaur Park Formation. Just talking about that. But we're lucky to have the help of an excavator and a skilled excavator operator right now, clearing away some overburden for us. This is work that we could do by hand, but it would take us literally months to do this. He can do it in just a few hours with that machine. So we're very lucky. So we can get down to the meticulous work here in the bone layer, digging up these fossils, collecting these data, doing all that. But, if anyone's here for the first time, which I'm sure some of you raiders are, welcome to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch doing some good old-fashioned science outreach. During the summers, I go out and do field work. I've been doing this since 2011, nearly every summer. And nowadays I get to bring you out into the field with me via the magic of Twitch and satellite internet. There's our dish right over there, the solar panel. So let me know if you've got any questions. The whole point of these broadcasts is for it to be live, interactive science outreach. Ask whatever you're curious about, and the other members of the crew will do our best to answer those questions for you and, you know, show you how all this works. But welcome, Montana Lex. We're here in Montana. Well. Also, Lexi Fitzgerald. And Dew Feathers. Dew Feathers says it was a fun stream. Was making a jungle habitat. Pokemon fossil exhibit. Oh, at the Field Museum in Chicago. Very cool. That's awesome. Thought this would be fun to check out your stream today. Really neat. Yeah. I wonder if any of the dinosaurs we're digging up here are represented in that exhibit. Maybe Lambeosaurus. We've got a pterosaur here, a big flying reptile. What the public often calls a pterodactyl. We've got maybe the most complete one from Montana here. So yeah. Anyway, and are you from Montana, Montana Lex? I lived in Bozeman for the better part of a decade, and we're out here near the town of Havre right now, just south of the Canadian border. This is a cool place. Oh, and we got a second raid from Shinkangadza. Thank you, Shinkangadza, for the raid. How are you all doing? The field work out here in northern Montana. Let me know if you've got any questions. Good stuff. Yeah, I hope you had an excellent stream. Welcome. And hi to you too, Shinken. Thanks for being here. Appreciate the raid. Yeah. And Luke Herman's Gaming says, I'm wondering, when you visit a different state as an American, does it feel a bit like you're visiting another country in a way? Not really. I mean, most things don't really change. Like, during the course of this summer so far, I'm from California. I went down to Florida for a week, for 8 days, and then back to California. And then I drove from California through Nevada, through Utah to Wyoming, and did some field work there for a couple weeks. And then I drove up to Montana a few days ago, and I've been here ever since. And then I'll be driving back home to California in about a week and a half, something like that. So, I don't know. You just drive. There's different state laws and stuff like that, and the license plates look different and all of this, but, you know, it's all one country. Different U.S. states have much more in common than they have differences, I would say. Yeah. Anywho. Oh, Glacier. Oh, very cool, Montana Lex. I was the best at making noise to ward off bears. Oh, gotcha. Nice. Cool. Yeah. Anyhow, we're staying a little bit later than I was expecting today. I hope that our battery doesn't run out. Let me go check on that real quick. See how we're doing power-wise. So I don't have to cut the stream short. We'll see. What are we at currently? Let's see. 29%. We're doing okay. I can hold on for a little while. But yeah. Good stuff. Yeah, I'm thinking we'll probably wrap up pretty soon. And what's the most interesting thing you found on a dig? Asked Montana Lex. Well, I was just talking about that earlier. Back in 2012, I personally found what should be a new species of horned dinosaur. Denver was talking about that a little bit earlier too. Hopefully it'll be published in the next couple years. But that was exciting. Yeah. Holy cow, that was a long time ago. 14 years ago is nuts. Doesn't feel like that long. Yeah. And thank you, Dewfeathers. Yeah, I'm not going to be an author on that publication. That's not my project. But I found the thing. Yeah. Anywho. But yeah. Cool. Oh, we wrapping up?
Yep, I think so.
All right, cool. Well, I'll go ahead and wrap up the stream and then put away my gear and everything. We'll get ready to go back to camp. I'm getting hungry. I'm about ready for dinner. But thank you everybody for being here today. Hope you had fun. I know I did. I'll probably be streaming from the same site tomorrow, but we'll see. Hopefully we get better weather too. But I'm Danny Anduza. This has been Paleontologizing. Thank you for hanging out with me today. Doing some field work out here. Don't go away just yet. We're gonna see if we can raid into somebody else who might be doing some science right now. Let's see. Following. Who else have we got live on stream right now? Oh, Belinda's live on streams. Well, well, well. We'll go see what Belinda's up to. Raid. Science. Streams. As the name would imply, Science Streams does have a thing or two to do with ants. Belint used to work on ants, modern ants, not fossil ones. But Belint is also a molecular and systems biologist, and his wife Lita also streams under the same handle. Sometimes they do joint streams. She's a geneticist and molecular biologist, if memory serves. And they do really cool science outreach, so you're going to enjoy this chat. Don't go away. But thank you everybody for being here. Really appreciate your viewership, your attention, your questions, your insights, your curiosity, and your financial support. I literally couldn't do this without the subscribers and the gifters and the cheerers, the people who make these streams possible through their financial contributions. It means a lot to me. Wouldn't be out here without you. And the moderators, mods, thank you so much for making sure that these streams stay all ages appropriate, positive, and that we stay on target with that science outreach. I really appreciate your efforts, mods. I really do. Thank you, thank you. Again, I'll probably be streaming from the same site tomorrow. We'll see. But tune in and we'll find out. Same time, same place. Everybody, I'll see you very soon. Let's go right into Science Streams. Take care, everybody. Let's continue the science right now.